In this video, we are going to learn about DBT, Data Build Tool. We will build a Netflix analysis project where we will take the data and upload it onto the Amazon S3. Then we will load that data onto the Snowflake database. Use DBT to transform all of these data by understanding the different DBT concepts such as snapshot, modeling, testing, documentation, macros, and many more. So you will learn everything you need to know about DBT in this single video. Are you excited? Let's get started. Before we move forward, let's quickly understand the architecture diagram of our project. Okay, it is pretty simple architecture diagram. We will be mainly working with the three different tools. One is Amazon S3, second is Snowflake database, and the third one is Data Build Tool, which we will learn everything about. Okay, now to start with, we will do the extract, load, and transform, and you will understand about this concept as we move forward in the video. We will extract data from the Netflix website. So we will be using a movie lens dataset that is like a Netflix. As we understand the business of Netflix, it's much more easier for us to understand the domain so that we can easily build the project and have the final analysis. Okay, so we will have the CSV file that we will upload onto Amazon S3. Okay, then we will automatically load our data onto the Snowflake database, which we will call as a raw landing zone. Once we have our data loaded onto the data warehouse, what we want to do, we want to divide our database into two different sections. One will be our staging data and second will be our development zone. Staging is basically getting the data from the raw and putting it in the staging so that we don't touch anything or we don't mess up with our raw data. Okay, in case we make any changes or if we lose some data onto the staging side, we always have the raw version available, so we can always go back to that. So it is basically like a copy of the raw data onto the staging zone. After that, we will do the transformation, testing, orchestration, and all of the different parts of DBT, and we will apply it onto the staging data, and we will put this onto the development database. Once that is done, then you can connect your database to Looker Studio, Power BI, Tableau. All right. After your transformation is done and the analytics reports are created, you can start creating a dashboard and share it to the stakeholders. So this is the whole project that we'll be doing. This is going to take around 3 to 4 hours. All right. So it will take time. Mainly our project is centered around the data build tool. So we want to learn as many as different things provided by the DBT, okay, so that we can upskill and also put all of these skills in our resume. So that is the goal of this video, is to understand the DBT in core. You will get the basics knowledge of the Snowflake and Amazon even if you don't know. Okay, I will give you the good enough understanding just to execute this project. But understand that our main goal here is to learn DBT. Okay, all of these different things just powers the DBT. So we'll be focusing on that, but our main goal is to learn DBT. If this is clear, then now we can move to the next section, Data Build Tool Masterclass. Hey guys, let's start with the DBT Masterclass, Data Build Tool. Okay, we'll be understanding everything. In the first section of this video, we will understand the basics of DBT, and then we will directly start with the project. While doing the project, I will explain you different concepts such as macros, models, everything about DBT while we execute all of these different things. Okay, but let's stop and let's ask the question that why do we even need DBT on the first place? What is the need? Why do we have to learn it? What is it all about, right? So we'll start with the basics first and then we will move forward. So first is the prerequisite, right? What are the different things that we need to know in order to learn DBT? First and the most important thing you need to know is basics of SQL, because if you don't know SQL, it is going to be really tough, because SQL, DBT, okay, is completely based on SQL. Okay, if you don't know SQL, it will be very difficult. So basics of SQL is needed. If you don't know advanced things, totally fine. You just need to know the basics, like how to write the select statement, CTE, okay, and some of the basic queries that we write in the SQL. So if you don't know SQL, if you don't have any understanding, I'll try to explain you while we actually do the hands-on practice. But if you want to learn SQL from scratch, I do have a courses available on SQL data warehouses. You can check the link in the description. Okay. Second thing is also you need to know the basics of Snowflake data warehouse. If you don't know, totally fine, nothing to worry about. I will actually help you out while we execute this entire video. But if you already know, good to have, right? It will be much more easier. And some of the data engineering foundation, it's good if you know about them. I do have a data engineering masterclass available on the YouTube channel. If you want, you can just check it out and revise it. But these are the few things you need to know. Basics of SQL is important. These two things are good to have, right? If you don't know it, totally fine. But if you know Snowflake and data engineering foundation, it is good to have, because DBT actually works on the serving layer, right? When we build our entire data pipeline, extract, do the loading thing and get the data from multiple sources, DBT works on the last layer, which is the transformation and the serving layer. We will understand about that when we actually understand everything. But let's start with the what is DBT, data build tool. Okay, at its core, DBT is a transformation tool that allows you to write modular SQL queries to transform raw data into analytics ready data models. What does that mean, right? It is a transformation tool. So it's pretty simple to understand that DBT is a transformation tool. So we know about the ETL, right? We extract when we transform, and we load data. We've been doing this till now. Transformation basically means we apply some business logics on top of it, right? When we remove something, when we add something, when we want to rename any column, we add two columns and create the new column. When we drop the null values, all of these operations are called as a transformation. So DBT is a transformation tool that allows you to write modular SQL queries to transform raw data into analytics ready data models. So you can use SQL directly, write it into the modular form. Modular basically means you can divide your SQL queries into different chunks based on the use cases, okay, and build your entire data model, which is basically build a small pipeline, okay, inside the transformation to get the data ready for the analytics, right? This is the basics of DBT. In short, it is basically the SQL data pipeline tool. You can say that, right? You can write transformation code, okay, directly on top of the data warehouse and directly start analyzing the data. Okay, so it removes that layer of ETL and you can directly move to ELT, which we will understand when we move forward. Okay, but in summary, it is a transformation tool. You can use SQL to write all of your transformation. That's it. DBT doesn't extract or load data. Okay, it focuses exclusively on the transformation steps in ELT. Okay, we'll understand about the ETL, ELT, all of these things when we move forward. But remember this: it is not a tool for extraction, not for the loading. It only focuses on the transformation. Okay, if this is clear, it will be much more easier to move forward. Remember this: you can use SQL to write the transformation code and then start analyzing your data. This is what the DBT mainly stands for. Okay, when we do the hands-on practice, all of these things will be much clear. So right now, just try to understand the concept. Okay, what we are discussing, just try to let the information flow. If you are very new to all of this, because when we start doing the hands-on, it will get, all of these things will get much more clear. Okay, so this is the architecture, or you can say the flow diagram of the DBT and where DBT actually sits. So you have the raw data, okay, then there is some things happening in the between, and then there is the analytics layer. Okay, below you have the data platforms. Okay, so this is Snowflake, Redshift, BigQuery, Databricks. I think this is Teradata. I'm not sure about it, but all of these are the data platforms. DBT sits on top of the data warehouses or the final data platforms on the serving side. Serving basically means when we do all of the extraction, transformation and everything, we load our data onto the data warehouse. In this case, we directly load our data onto data warehouse after the extraction. All right, here let's say our all of the data is available. DBT will connect to all of these data warehouses such as Snowflake or BigQuery or Redshift, okay, and then perform all of these operations on top of it. What are these operations? First, we have the raw data available as it is onto the data warehouse. It might be available over here. All right, it is available. Then we can develop, test and document and deploy our entire transformation pipeline onto DBT. All right, we can develop. First we develop, like we start writing code, we understand what we need, what are the outputs that we need. Then we test and document. DBT allows you to test your code directly, okay, properly. And then you can also document. You can directly generate a documentation based on the code that you have written, so you don't have to write it manually. This will get clear when we actually do the hands-on practice. And we can directly deploy the pipeline so that it can automatically run. Okay, so these three things you can do it onto DBT itself. And then we have the final data set, which is the transformed one, which can connect to any BI tool like Power BI, Looker Studio. We can use it for the ML models, or if you want to do just basic analytics, you can do all of this. But remember, DBT directly connects to the data warehouses or any data platform. Okay. After that, you start using DBT to write SQL code. Before that, we will just extract the data and load the data. This is a more detailed version of DBT. Okay, this particular thing that we have seen here, okay, this is just a high level kind of like the diagram or architecture, but this is a more detailed version of individual components that we have available. Okay, so we have seen data warehouses are bit of data platforms like Snowflake. It will be like BigQuery is available over here, and Redshift is available on the bottom. Okay, which is kind of like we are stacking DBT on top of our data warehouse. In simple, we are just connecting it. Okay, this diagram are just for the illustration purposes. Okay, that doesn't mean that DBT sits directly on top of the data warehouse. It's basically we are using some kind of code or connection URL to connect to the tool. Once we connect, okay, this is what happens between the DBT. This is entire thing. So the first thing, we have the data loaders. Basically, we have our data available onto our data warehouses. We make a connection, DBT connection with the data warehouses. Okay, then these are the different things available in DBT, like snapshot. If you want to capture a particular snapshot, right, you can do that. You can transform your data, you can test your data, you can deploy the pipeline, you can document it, you can do the version control using Git, you can do the alerting, you can do the logging if you want to understand what is happening in your pipeline. Okay, all of these things happens in DBT. These are the different individual feature or component available inside the data build tool. Okay, and then you get the transform data. So raw data is here, transform data is here. In between, whatever happens here is DBT. Okay, you can snapshot your data, transform it, test it, deploy it, document. We'll understand about the snapshot in detail. What is transformation? How do you actually test the data? Okay, what is the version control, logging, document? All of these things we will try to understand when we do the hands-on. Right now, just understand the basics, like what is available right now. Okay, or what is DBT on the higher level. We will dig deep dive into individual things when we move forward. Okay, DBT overview. Now, before we understand DBT, it's very important to revise the data engineering lifecycle, because in order to understand the analytical engineering side, okay, or the DBT side, serving layer, we need to understand what is happening before that, right? How do we actually get the data? So in general, in data engineering pipeline, you have, right, we have the data generation, data coming from the multiple sources, such as we have the APIs, we have the DBMS, okay, database RDBMS, you can say. We have the website. Lot of data are coming from the here, and data gets generated, right? You use application, data gets generated. Now this data gets ingested into some kind of system. So in data engineering lifecycle, we have like ingestion, transformation, and serving. So we ingest our data, okay, that basically gets stored onto the storage. Then we transform our data, and then we serve our data. At the end, serving happens for the analytics, machine learning, and reverse ETL. Basically, we put our data back to this. This is the basic foundation of data engineering. I have covered about this in very detail on my data engineering masterclass. Okay, you will find the link in the description, or you can just search it on the channel. You will find it, right? Very detailed version, but this is just an overview, right? And then we have the undercurrents that actually supports the data engineering life cycle. Very simple, right? Data engineering life cycle works on these core foundation. Now this is the actual architecture of how the real data engineering project looks like. Okay, there is no DBT, there is nothing here. This is just a simple architecture of a app called as a Dream 11. It is a fantasy sport betting app, right? You can bet on the teams, like if you follow cricket, football, right? If you want to bet on something, create your team, you can do that. So this is the data platform, right? We have covered this in our masterclass also, but this is the basic data platform, and I just added this here just so that you understand how the real world platform actually looks like. Okay, so over here, when we talk about this data generation side, all right, it is available here. So all of these things are basically generating our data, right? You have the MySQL, VoltDB, Cassandra is doing something like these are the user transaction flow, and this is like the website and the app user behavior flow. All of these data, okay, third party data, and all of these data goes to Apache Kafka, which is a data ingestion mechanism in this case, right? Again, data engineering lifecycle is just a concept or the flow diagram how the data engineering should work. this is the actual implementation in the real world. Okay, tools are just used in a place of different places. You can replace any tools and make it work. Okay, so Kafka is ingestion, then we have the Apache Spark for the transformation, there will be Amazon S3 for the storage, and then this is like the serving layer side. Okay, Presto is used for the serving, and then you can create the Looker Studio dashboard or send it to the third party vendors or do whatever you want. Okay, this life cycle is basically following. Okay, this architecture is basically following this kind of data engineering life cycle. Okay, there is a ingestion, there is a transformation, and there is a serving layer. Okay, and then there are some other elements that are attached to it. If this is clear, the data engineering foundations are clear. Again, there is more to it. Okay, masterclass is available, you can always check that, but you don't really need to know everything right now. This is enough to know. Okay, so where does the DBT actually fit in? So if you see this entire diagram, right, where does the DBT fit here, right, in this all of these place? Okay, DBT works with the data warehouses. Remember this. Okay, it directly works with the data warehouses. It has nothing to do what happens in the data engineering side, right? The ingestion, transformation, or the serving, storage, all of these things are fine. Okay, DBT works just with the data warehouses. So this is the similar diagram, okay, but in a different order. So we have the extract, then we have the load, and then we have the transform. Remember, this concept works mainly on ETL. You have the extraction here, you have the transformation here, and then you have the loading or serving, you can say. DBT works on a different concept called as a ELT, extract, load, and transform. The load and transform, we have just reversed it. Okay, so before transforming, we load the data. Now you might say, Darshil, don't we need to transform our data before loading to the data warehouse? This is a common thing, right? Because we extract the data, it is coming in the multiple type from the multiple sources. Everything is different. We have to structure it, then load it to the data warehouse. But in this concept, we are directly loading it and then we are transforming it. Why do we even need to do that, right? That is a valid question we might have, right? Before transformation, how can we even load our data to a data warehouse? The answer to that is given over here. Okay, so don't worry about it. Now see here. Okay, we have the extraction, we have the source data set, source API, flat files, everything is available. We extract our data, so all of these files are stored onto some kind of storage location. Let's say this is our S3 bucket. Okay, it is actually stored over here. Okay, and DBT can actually load this data directly to the data warehouse, okay, using something called as a seed file. We'll understand that. You can seed your data. So let's say you have a CSV file available on your local storage. You can directly create a table using DBT. Okay, you don't have to manually, create a schema, upload it. DBT will do that for you. You can transform your data, orchestrate, and also test it. So you can create your entire data pipeline over here, okay, onto the transformation stage only, and then directly serve your data for the Looker Studio Power BI. Okay, this part is completely DBT. Okay, so in this case, right, you understood, right? If we were to load or serve our data, we have to ingest it, we have to do the transformation, we might have to do the storage, and then after doing all of these different things, we actually go to the serving layer. This is a much more simplified version, but here we have a data, we extract, directly load it to the Snowflake, and then we can do anything we want onto DBT only. We don't have to use anything else. Okay, this is the power of DBT. You do the transformation at one tool only and directly serve it to the final stakeholders, machine learning engineers, data scientists, by writing the actual code. Okay, if this is clear, then we can start moving forward. That why do we even need DBT on the first place? You say, right, okay, this is working fine, ETL is working fine, this architecture is very scalable, we use Spark, we use S3, Presto, Redshift, and everything. If this is working fine, why do we even need DBT, right? We've been using ETL. What is the need? Okay, before DBT, transformation work was often done through first SQL script. So manually you maintain the SQL script, right? You write all of your SQL script into like multiple files, then you do orchestration of that SQL files manually and actually manage all of these things by yourself. Okay, there was no version control. So let's say you wrote a transformation in SQL. maybe inside the PySpark, right? And the data scientist comes that, okay, we need more 3 columns, we have to remove 1 column and rename something. You will go manually edit all of these things, and backfill all of the data, change everything. This is a repeated process, it keeps happening. This is what we've been doing, right? We were manually maintaining everything, and there was no version control when we actually changed the script. You can still put it onto the GitHub repository and make the versions of it, but uh, it was very difficult for us to do that. Then ETL tools, so complex and expensive ETL tools that require specialized knowledge also. So a lot of enterprises use these like Alteryx Informatica to actually build the ETL flow. You can use Apache Airflow to actually write some of the basic ETL. Do have the Apache Spark. You need a expertise to handle all of these different tools, right? You have to manage them, maintain them, everything is required. So they're quite complex and also expensive. Running Apache Spark on large scale is very expensive also. And custom code, right? We use Python, Scala, and other programming language to transform our data. So in one pipeline you might have like multiple different languages being used: SQL, Python, PySpark, Scala, Java, based on the requirement. Okay, you might use that. And if you don't have the resources available to actually manage them, it gets very difficult. So what is the problem is that it is very difficult to maintain. Don't have the proper testing mechanism. Poor documentation, right? Dependency management. So if one person is doing something, I have to wait for that person to finish and then I can do something. And again, collaboration difficulties, because it is a large scale project, right? How do I even collaborate with all of these different tools? You have to like proper have a communication, make everything into the structure format, then we can move forward, right? So why DBT? Okay, it gives you the modularity. Okay, breaks down the complex transformation into the manageable pieces. So let's say instead of writing 1,000 lines of SQL code, that looks cool, right? Oh, I have written the 1,000 lines of SQL code, but while writing it, it is fine. But when you have to manage it, when you have to change something, right, when you have to add few things, remove few things, it gets difficult, because the as the lines of code increases, the difficulty of managing it also becomes harder. Okay, so DBT helps us to break down our SQL code into different pieces. Reusability. So if you have like some pattern or some kind of table that you might want to reuse again and again, you can easily use it across your project. Then testing framework, so it also has the built-in testing capability to make sure your data quality is fine. Okay, you can have a like rules written that, okay, no null value should be available into this column. The name of all of these columns or the data type of all of these column should be integer. No other value should be added. So you can also do the testing thing. Document generation, so it automatically generates the documentation based on your data model, right? Let's say you have written like 15-20 files, right? Now you have to write the manual documentation. No, in DBT you can directly generate a documentation with just one single command. Okay, and you will get the beautiful representation of your entire data pipeline. Dependency management, it automatically handles the order of execution of the model. So let's say you have like written the 10 SQL files, and if you want to execute them into the proper order, you can easily do that. And then development workflow, right? So you can create the separate environments such as dev, testing, or the production, and actually execute your all of the pipeline. Now let's try to revise some of the foundational concept before actually we start doing the hands-on practice, because it is very important. First is the data warehouses, right? A data warehouse is a central repository that is designed for storing and analyzing your large volumes of structured data from the various sources. We already know about this, right? We have the ETL. Okay, we extract, we transform our data, and then we load our data to the data warehouse. Previously, all of this data warehouse required the structured data only. Now the modern data warehouses such as Snowflake, BigQuery, okay, they can handle any type of data, right? Structured, unstructured, semi-structured. You directly dump your data. That is why the tools like DBT is powerful or so popular, is because the capability of data warehouse is changed, right? You directly dump any data you want, and then based on your requirement, you can write the transformation logic. So it removes a lot of dependency issue. Then we have the data lake also. Okay, it is a storage repository that holds the vast amount of raw data into its native format. Now the problem with data warehouse we already knew, right? We have to transform our data. Previously, like before all of these modern data tools, we had to transform our data before loading it. That's why the concept of data lake came. It said that Don't worry about transformation, don't worry about anything. Okay, just dump your data onto any storage location like Amazon S3, and then read your data as per your requirement, right? So whenever you, let's say you just need to use the uh, three columns, right? Instead of doing ETL loading, transforming data to the data warehouse and then using three columns, why don't you just read the three columns from the S3? Okay, there are tools over here in this diagram if you remember. Okay, this is a data lake. That basically means our data is coming and put onto the S3. Okay, and then you can use tools like Amazon Athena. Okay, let me just zoom this. Amazon Athena to actually write SQL queries and then serve to the different user. This gives you ad hoc analysis, basically the power to only use data that is required. Over here, we do the ETL and then we load our data to the Redshift. This requires a proper set of core transformation logic that is stored onto the Redshift, which is the final data warehouse available. So one is we were using data lake for the ad hoc analysis, only work on the columns that we need, and here is the most structured version of the data is stored. Okay, so that we get the proper data if any user is needing that. Now the combination of these two is basically a data lake house, because we need the both capability. We also need a structured data, but we also need the access to some of the data that might not be available onto the data warehouse. This is where the data lake house comes into the picture. All right, if this is clear, then we can move forward between data warehouse and data lake. We already understood, right? In data warehouse, the data is properly processed, organized into structured format and then stored. But in data lake, raw and unstructured data directly dumped into the storage location. For analysis, this becomes easier, and here you only read the data that you need, right? The one last concept is called as the ETL versus ELT. We just touched upon it, got the overview, but let's just dive into it little bit so that we understand it. In ETL, again, we have like multiple system, okay, sources available. Then we do the extract, transform, and load to any data warehouses. For example, extraction from all of these different sources that is coming here. Okay. Then we do the transformation. Transformation basically means we want to filter some data, we want to mask some values, such as we are using a address information or credit card information, right? So instead of, let's say, credit card number is 1234, we will have like XXXXX something. Okay, 1234 or some. So let's say the 12 digits of credit card number, 8 digits will be masked with the XXX or some hash or something like this. So masking is done on the transformation. Joining of two different files or tables are done on the transformation, and then we load our data to data warehouse. This is more structured approach, right? There is a structure into the entire pipeline. ELT, on the other hand, replaces the position, right? So again, data is still coming from here, extraction, but we directly load our data onto a data warehouse. Okay, which basically you do the schema creation, like create table based on the files available, you do the mapping. Okay, and then you automate this entire process of data loading, extract, and directly dump your data onto the data warehouse. Here where DBT will come and actually do the transformation at the end, right? The transformation will happen here, where you can write, test it, build models, create your entire SQL transformation pipeline, and then serve it to the user. This is the difference between ETL and ELT. Okay, now modern data stack, right? Again, remember that, right? We've been using the legacy tools till now. Lot of issues with that also, right? Spark is expensive. You have to write a lot of code, changing of schema, backfilling data, lot of different problems, small problems available when you do it on the large scale. Now these are the modern companies who come and say that, okay, on enterprises you have this problem. What we are doing is that we have built a modern tool to fix your issue, right? We are going to fix all of your issue right now. Okay, if you use our tool. Okay, and these are the modern data stack that we call, right? These are designed for the modern problems, trying to create a business by fixing all of these problems. This is how the industry works, right? You start with the Hadoop, then you go to Spark, then you go to any Databricks. you just keep building on top of the existing solution and try to make it better, right? You move forward, right? This is what the concept of modern data stack is all about, right? For every different thing like sources, storage, transformation, processing, output, we have the new tools available, right? We also use the older tools, but also we have the new tools. For example, for the storage, we were using Amazon S3, but now we can use a Delta Lake, Iceberg, which is basically the open table formats available that gives you more feature. We have talked about the this open table formats in one of the video. If you want, you can check it out. Then we have the SaaS apps like Stripe available. S3 Direct you can store, segment for event tracking, Salesforce. In all of these things are generating the data. You can use tools like Hevo Data or Fivetran, okay, to actually create a pipeline between directly from the source system to your storage system. Instead of writing the Kafka or ingestion mechanism, you have a direct tool available. You connect to the source, you connect to the destination, and it will automatically start flowing. These are the modern tools, Fivetran or Hevo Data, that you can use. Then we have the transformation like DBT you can directly use to move forward. Then for the processing and querying, you have the Athena available, Dremio available. For streaming, you have the Kinesis available. For output, you have the Looker, Tableau, Power BI, and all of these different things available. And also we have the orchestration framework like Prefect, Airflow, Daxter. Again, modern tools solving a different problems based on the use case. You use them. You don't have to know everything about the tool. Okay, you just have to know the why do we, you only need to know that why does this tool exist on the first place. You just need to know like what is the use of DBT, what is the use of Prefect, right? What is the use of Iceberg. If you understand the entire picture, then you can actually, after the foundation is clear, then you can actually understand, okay, Iceberg solves this problem, okay, Prefect this solves this problem. You don't have to master the tool till you need it, right? When you go to the job and they told you that, okay, we use the Prefect for our data pipelining, then you can go and learn the tool. Without that, you don't even have to consider that, right? You just have to focus on the core foundation. Let's say Apache Airflow is there, S3 is there, the data engineering foundation, and the tools that we've been using, let's say Apache Spark, Kafka, and all of the different things. Okay, now this is what the modern data architecture looks like. Okay, we have just saw the tools. This is like the sort of more matured way of doing it, like we've been doing this till now. So grow out of this and start moving. Then you can start replacing some elements from here to here to build a modern data pipeline, which is by using the modern data tool. So it might look something like this. Okay, this is just an overview architecture. So you have the orchestration, you can use Prefect, Airflow, Daxter, modern tool. For the sources, let's say all of these different sources are available. So again, an application is connected to the multiple sources, right? Let's say I have my website Data Vidya. For payment gateway, we use Razorpay and Stripe. Okay, so my all of the transaction data goes onto their platform. For analytics, we have the Google Analytics to track the amount of users we are getting. So data for the analytics goes to that platform. Every time users does something on our website, we store it onto our databases. So we have the multiple databases available, the sources available. Okay, like this, you have the Stripe, you have the PostgreSQL, Shopify, Google Ads. Data sources are multiple. These modern tools such as Fivetran, Stitch, Airbyte, you can use Python, Spark also, okay, the older one, can directly connect to this and directly load your data onto the data warehouse, right? You make a connection with the source, you make a connection with the destination, it starts flowing your data. Data warehouses, modern data warehouses, BigQuery, Databricks, and everything. Okay, you can use DBT. Okay, on top of this to create the landing area, staging layer, warehouse layer, and mart layer. We will understand about this, but in basically raw data comes to the landing zone. Okay, then we don't touch this landing data. Okay, this is just our raw data. If we want to make some changes, we put it onto the staging layer or directly replace it, like maybe change few column names or do the little bit structuring. Okay, then we have the warehouse layer is like the final proper structure format, and then mart layer is for the different use cases, right? And then we have the Looker Studio and everything is connecting, and there's a reverse ETL available. So you use this data, put it back to the, let's say, Facebook ads, Google ads, to actually target the right set of people for your product. This is the modern data architecture. Again, if you don't understand everything right now, totally fine. Okay, all we are doing is that just setting the foundation for the DBT, because when we actually start doing the hands-on practice, you will think, okay, why am I writing macros, why am I testing, why am I doing testing like this, what is the need of models. It will all get clear once you understand what and understand the entire picture, right? If you just learn the DBT tool, you will only learn the tool. But if you learn where does the DBT actually fix and what can I do with that, it clears more things. Okay, this was everything. Now let's directly start with the DBT. Now before we move forward, I just want to say a few things. Okay, uh, again, while doing the project, we are going to face some issues. We are going to face some errors. So uh, if you do, I'll highly suggest you to first chat GPT. Okay, use AI, integrate that into your workflow because it actually helps you to solve a lot of issues, or not just do the Google or read the documentation, right? Most likely you might not face it, but if you do face it, we are going to use that. Okay, second thing is, if you are new here, then make sure you like this video. Okay, because all of this video takes so much time, so I appreciate if you like the video, and if you are new, then subscribe to the channel, so uh, it will help my channel to grow. And yeah, and thirdly, I'll say that watch the video till the end so that you actually complete the entire project. And if you do like it, okay, share it across the social media, build your portfolio, and move forward. So let's start the execution of our project. So let's start with our project execution. Now, in this project, we are mainly working towards the uh, DBT side, right? We want to mainly understand DBT and build a complete project. Now, before that, we perform some data engineering, right? We extract data from the multiple sources, and in this case, we will directly load our data. So we require two things. One is a good data source. We will be using the movie lens data, which basically stimulates the example of Netflix, right? So we will use that as an example to actually process that data and analyze that. And second thing is, we will be working with the snowflake database. Now again, there are multiple data warehouses available. We have the BigQuery, you can use the Redshift. We will go with the snowflake because it has the 30 days free trial, so you won't be charged, and it is easy to use, and it's a good thing to add it in your skill set, right? So we have talked about the prerequisite. Now if you want to deep dive into the snowflake, again, I have a course. You can always go there and actually learn everything about it, but in this video I will give you the good enough understanding of snowflakes to perform this project. Okay, so that you don't have to really enroll to the course. But if you want to deep dive, upskill yourself, I have a courses available. You can always check them out. Okay, so let's start with our project execution. So you can go to first step is that we get our data, right? And we want to load our data to the snowflake. So this is our first step, right? First I want to have my data source. All right, this is my data source available, and now this data source I want to load it, right? So in this case, our data source is movie lens, which is like a Netflix. Okay, we will use the example of Netflix because we understand that particular product, so that it's easier for us to analyze the data, right? If you just use the movie lens, it's very difficult to understand the business side. But if we take the example of some company like Netflix, it's much more easier to actually analyze the data. Like, you build a domain understanding, and then we will load this data, okay, to snowflake. Okay, let me just change the color of this. Okay, we will load this data to snowflake, and then we will apply all of the DBT here. DBT. Okay, so this is the clean execution. Major time will be when will be major time we will spend on the DBT side, because we don't want to worry about just the loading. The data loading, we will keep it on the, we will upload our file onto the S3 bucket, and then we will load that to the snowflake. So I will explain you everything, nothing to worry about. We will do everything from the scratch. Okay, now the data source is available onto this website called as a grouplens.org, movie lens slash 20m. Okay, 20m is a movie ratings. Okay, so movie lens 20m movie ratings, stable benchmark for around 20 million ratings, with around like 465,000 465,000 tag application applied to the 20,000 movies, and around like 138k users. All right, we are not much concerned about what the data set is. What we want to do is we want to perform some analytics, run some DBT models on top of it, so that we understand the technology and how to actually use that in the real world. Okay, so you can download this data by clicking over here. I will also upload this data onto the drive if you want, but if you just click here, it will just start downloading the data, and you can extract the zip file. Okay, so if I click here, it will start downloading here. Okay, I've already downloaded it, so I'm not going to download it again, but it will take around like 5 to 10 minutes depending on the internet speed, and you will get the data. Let's spend some time to understand what this data is all about, because it is very important to understand what are the different files are available. Okay, so just click onto this readme. Okay, and here you will find everything about this data set. Mainly we are concerned about different files that are available. So first is a rating file. Okay, it is like a ratings.csv. All ratings are contained in this file. Okay, first row is the header row. Okay, and it has like user id, movie id, rating, and timestamp. Right, the lines within these files are recorded by the user id. Then within the user we have the movie id. So we have the user id and the movie id available. Ratings are on the scale of file 0.5 to 5. All right, and timestamp are represented in a utc times format of like this. All right, we understand the ratings have the rating data with the movie id, user id, rating, and the timestamp. Then we have the tags. Okay, all the tags are contained in the tag csv, represents one tag apply to one movie by one user. So there is some kind of tag that is being applied. Okay, again, user id, movie id, tag timestamp, lines within the recorded by the user id, then the movie id. Okay, tags are user generated metadata about the movie. So you can say the users are writing some kind of tag for that particular movie. Okay, can be considered as a feedback. Okay, each tag is a typical single word or a short phrase, meaning the meaning, value, or purpose of particular tag is determined by the each user. So user is writing, and then we have the timestamp. Same, we have the movies csv. Okay, it has the movie id, title, and the genre. All right, and the genre can be depending on the action, adventure, animation, and all of the other things. Then we have the links. Okay, identify identifiers that can be used to link other sources of movie data containing the link CSV. All right, it has some kind of links such as movie IDs identifiers like the movielens.org, IMDb, or the movie DB, which is basically they are like referring the third party sources as a link for some kind of rating or something, right? Just a higher level overview. And then they have the score and the tags. Okay, uh, this is included in the tag genome. Okay, it's a data structure that contains the tag relevance score for the movie. So how relevance a particular tag is to the movie written by the user. Okay, it is like a matrix. Okay, each movie in the genome has a value, every tag is a genome. All right, there's some kind of genome that is being attached, which is kind of like the rating all of the tags that is being attached to movie. Totally get it, right? A good data set, multiple files, we can use this to analyze something, right? Consider this from the Netflix point of view. Netflix has a lot of movies on their platform, right? So each movie has a ratings, tags attached to it. Okay, movies, all of the movies name, then the links, if they are using some third party thing, or the ratings for the third party, they can also include it on their platform, and the genome score to actually identify if the user ratings are correct or not, something like that. Okay, everything. Okay, now if you have downloaded your data set, okay, there are two ways we can actually, not two, there are three different ways we can actually load our data to the snowflake database. One is you go to the snowflake, directly create a table and upload your files. It will do everything by yourself. Okay, so you can upload from the local file storage system, but it has some limit. So before, yeah, I'll tell you how to create a snowflake account, but I'm just showing you right now how it looks. Okay, let's say if I go here, and if I go to any sample data, let's say this. Okay, and inside this, not here, public tables. Okay, if I want to create something table from file, snowflake has like 250 size limit. Okay, you can directly create a table from your local, and it will directly upload your data to the snowflake. Okay, we'll come to the snowflake part, but I'm just giving you the example that one way is you can use the snowflake database UI to upload the data. Second way is that you upload your data to Amazon S3, something like this. We will follow this approach where you load your data to the Amazon S3, use snowflake to connect to the S3, and then load your data to the snowflake. Much more cleaner way, because you will use the copy command. If you add more files, like if you have like 1 GB, 10 GB of files, you can easily do that. So this is second way. And the third way is directly we can use the DBT to actually load our data. Okay, In the DBT, we have something called as a seed concept, right? Is basically if you want to create a table using the local file storage system. Okay, if you want to create a table based on the file that is stored inside the DBT folder, okay, you can do that and it will create a table on your data warehouse. We will do that as an example to see how it works, but we are not really concerned about that right now. Okay, what you have to do in this particular example is that you have to have the Snowflake account and the AWS account. Okay, so I'll first show you how to first upload your file onto the AWS. So it is pretty important that you have the AWS account with you. If you don't have that, you can just do aws.amazon.com. Click onto the create new account. Just fill all of the information. Remember, they will ask you for your credit card details. All right, just to verify that you are an actual user. They will not charge you anything, and this project will not cost you anything at all. Okay, mostly you will be able to do this entire project for free, so that when you create your AWS account, they will ask some information. Just fill that and get the account created. If you already have the account, great. Okay, you can move forward. If you don't have that, just create it. If you don't know, just Google it, how to create AWS account, and you will find lot of different blocks AWS account, and you will find a lot of different blocks available to creating AWS account. Not that complicated. Once you are on the AWS account, you will see something like this. Again, this is my personal AWS account, and it has a lot of things going on because my data vidya server runs here and a lot of things are going. Okay, but mainly what we're interested into the S3. So you can just come here and just write S3. Okay, this is a simple storage service used for storing all of your files, creating a data lake, and you can do whatever. Now here, click on to the create bucket and give some bucket name, right? In my case, I have given like Netflix dataset, but remember the bucket names are universally unique, so that if I use this bucket name, it cannot be used across the AWS universe. All right, so if I just try to use this and click on to create, it will give me the error that the bucket name with the same name already exists. So if you want, you can attach some number by, or you can just attach your name, something like this. All right, you can do that. Other than that, everything is fine. Okay, over here on top you can see I'm using this region, but AWS S3 uh, is available across all of the region, but you can use your primary region as per your location. So if you want, I can go to the North Virginia and also create the bucket onto that particular region. So in my case, I'll go with the Mumbai because it is the closest to my location. You can also choose the region based on your location that you stay, and then create a bucket. So just give the good name like Netflix dataset, uh, DBT learning, yeah, DBT learning. All right, if you want, you can attach your name also, and just go below and click onto the create bucket. Once you do that, I already have it available, so I'll just show you. Okay, Netflix movie data available here. Upload all of your files that you downloaded on the zip folder. Okay, extract it and upload it onto the Amazon S3. It will look something like this. There's an upload button. Click onto this. You can directly, let's say if I want to upload, I can just select. Don't select this readme file, we don't need this. You can directly drop it, or you can click by add files or add folder, upload it one by one, and click onto the upload. Once you upload it, it will automatically get uploaded after a few minutes, and you will see your files. So this is the basic data setup that we are doing. Now in real world, what will happen, right? If we have any project, let's say, let me see, let me just give you one example here only. Let's see, Kafka is available. Mm, okay, it's not available here. Let me go to this website itself. Okay, so yeah, so we have one of this project available onto our Apache Kafka for data engineering course, right? Now in this project, what we do, right? We extract data, stock market data from the multiple sources. Then we use Kafka to actually do the ingestion, use Apache Spark to process the data, okay? And then load it onto the Snowflake database. So in this case, data comes from the Kafka and the raw data gets dumped over here, okay? Now, this part you can consider using on the little bit side on the data engineering side, right? Will we do? What we are doing in this project, the DBT project, we are starting from here only, which is the raw data set that you see, right? Using the raw data set, we are assuming that our data is coming from the multiple sources and getting directly dumped onto the S3 bucket. Now what we need to do, okay, this is what we are going to cover in this project. We are not going to cover this side. We have just we are basically manually doing this work. But assume that in the real world you will get data from the multiple places and directly being available to either on S3 or any storage system, right? And then you start doing your loading work. Or else you might already have your data available onto the snowflake, right? Not on S3 but directly available onto the snowflake by data engineers might be doing that, or some kind of, or maybe by some other data engineers or some engineers who already uploaded or loaded your data onto the snowflake. And then your job might start to create a DBT models on top of it. So there are multiple use cases, but in this case, we are starting from here. We are not going through all of the previous work because we have covered all of these things a lot of times. Okay, so we want to start from here. Okay, in this case, we are using the Netflix movie dataset, and then we will load our data onto the Snowflake. So let's move forward. Now, our AWS is ready. We have our data available onto the S3 bucket. Now, what we want to do, we need our Snowflake. So you can just go online, just write Snowflake. Okay, sign up for Snowflake. If you don't have the account, you get the 30 days free trial. You can use that and you won't get charged. Just pull your first name, last name. You can use your personal email also. And then I'm a student exploring Snowflake. Let me give the example. Darshil Parmar, Darshil Parmar 33. Let's say I'll use some email. Okay, I'll move forward. School name, you can give whatever the school name that you are. Okay, uh let's say University of Mumbai. I'll just give MU. Okay, you can select standard, enterprise and business critical. Just go with the enterprise. Okay, select AWS, region, nearest region that you can think of. Get started. When you click get started, it will create your account. It might ask you some of the survey information. Once you do that, you will get something like this. Just skip this. It will send the email. Okay, on your, you will get all of the information about the account identifier and everything. And then you, using that, you can actually set the password and log into your account. Once you do that, again, it's pretty simple steps. We don't really need to know anything. If you want, you can just Google the information and you will find that. Okay, once you actually log into your account, Snowflake account, you will see something like this. Okay, if you're seeing this UI for the first time, it's very simple, not that complicated. Also, they keep changing the UI, but this is pretty simple. We have the home where all of the information that you do, like recently created SQL worksheets are available. You can directly search across all of the different things. Then we have the projects. Inside that, you have the worksheet or notebooks, right? Then you have the Streamlit dashboard. If you want to create that, you can do that here only. Then you have the data. This is the where all of your databases, tables, views will be stored. What is this? Yeah. Okay. Then you have some of the data products available, third party if you want to integrate, AI model monitoring if you want to see what is going on. So all of these different things are available. Again, I have covered all of these things in detail. I'll just show you here. All right. If you're interested, you can go. This is my again data warehouse Snowflake, and we have like the proper section of the Snowflake deep dive where we talk about everything Snowflake, time travel, drop, types of tables, zero cloning. Okay, you don't need to know all of this for this project. Okay, this is the Snowflake UI we have available. Now what we want to do, we want to create some users on top of it so that can connect to the Amazon S3 and start doing the work. All right, so for this, click onto this create. All right, and SQL worksheet. Right, and yeah, this is pretty much, I'll put this inside, and here you can start writing your code. Let me see. Yeah, I think this is fine. Right now nothing is created. So first step is to, either we can use our own Snowflake username that is given to us, which is basically, if you click onto this corner, okay, left down, left bottom corner, and then if you click onto the connect to a tool, okay, connect a tool to a Snowflake, you will see all of this information. All right, we have the username available. You can use this username. Then you will have to use your root This is your root username and root password you'll have to use to connect. What we will do, we will create our internal user so that we can use that to actually connect to Snowflake. Okay, so I have created some commands. All right, we can use that to directly work with it. Let me copy this so that you guys can put it here. You will find all of these commands onto my GitHub repository available. You can copy from there also. All right, but this is, I'll just explain you command from the basic. First is we use the admin role, so you can select it and run it using this button. All right, first what we'll do, statement execute successfully. It now it is using the admin role over here to execute all of the queries we have. All right, now we want to create a role. All right, create a role as a transform. Okay, and we give the access to this transform to the account admin, right? So it has the similar permission as the account admin. Create a transform role and assign it to the account admin. Now create a default warehouse. So all of the queries that you run, all right, will be executed onto this particular compute warehouse. Okay, it is done. All right, then we create a user. All right, this is like a user that has the access to the. Then we create a DBT user, okay, and assign it to the transform role. So all of the permission that is attached to the transform role, this user will be able to execute, which is basically the admin permission, right? We'll execute this. All right, after this we create a database, okay, and the schema. So movie lens, you can give the Netflix here if you want. All right, and I'll give the Netflix here also. Okay, and we execute this. Let's just stick to movie lens. All right, because we are using the default namespace here as a movie lens, so we'll use the movie lens, right? After that, we can grant all of this permission. Basically, we are granting the this data warehouse. Let this complete. All right, data warehouse access, database access, schema access, future schema, and all of the tables, all of the future tables to this transform role that we created. What we just did is basically we created the role, okay, that has the customized access, and also user that has the permission to go through that role, so that in case our credentials even get leaked, right, that person will have the limited access to our entire Snowflake, right? If you use the account admin directly or your root access, person can actually change a lot of things. So this is what we just did. We just created the one single role and the user. Now we want to start loading our data, okay? And to load our data, we need to connect to the this Amazon S3. So I'll start with the new worksheet, okay? What is this? Let me, yeah, reset this. I hope you guys can see all of this. All right, now just click onto this plus icon and start the new worksheet. And here we will first create the integration, okay, with our AWS account, right? We want to connect to the AWS, so first we will create the integration. Now again, there are multiple ways you can connect to the AWS. One is directly using the stage, okay? You create the something called as a Snowflake stage. If you just Google it, Snowflake stage, stage, right? It is basically, if you want to connect to the external source and actually load your data, okay, to the Snowflake table, you can create a stage to it, or you can create a storage integration, right? Snowflake storage integration, this is more secure way, the storage integration one, because you don't have, you actually create the internal permission to access the data. A storage integration is Snowflake object that stores the general identity access management entity for the external cloud storage. In this we will just use the stage, right? But it is a good practice that you use the storage integration. Again, we cover all of this into the course, but right now we want to just follow the simple way because we are not concerned about the data loading. What we are mainly concerned about is actually executing the DBT project. Okay, so let me just go and just, you can start writing like create, okay, stage. I'll just show you one command, okay, then I'll just write like Netflix stage, okay, URL. Here you have to give your S3, so S3 colon backslash slash, and then give the bucket name, which is in my case it is Netflix movie data, all right? And then it requires the credentials. Credentials is equal to AWS underscore key ID, okay? It will have something, and AWS secret key, it will have something. Now, where do I get this access key and the secret key? Go to your AWS, okay? Open a new tab. Over here, right? IAM, Identity Access Management. Here, where you actually manage all of the AWS account, roles, permissions, and everything. Click onto the user, create user, okay? And okay, click onto the user. Let me go slow. Create user. Give some name. Let's just Snowflake. Snowflake. Uh, Netflix user, okay, something like this, okay. Click onto the I don't want to give the console access. Click onto next, okay. Click onto this attach policy, all right. And over here, either you can just give the S3 full access, all right, or you can give the admin access. We'll just go with the S3 full access. We need all of the access for the S3. Click onto next. Click onto the create user, okay. So I'll go here, Snowflake Netflix user, all right. Now click onto the security credential. Over here we have the access key tab. Click onto the create access key, all right. Over here you have like a lot of different things. We'll just use, let's say, local code, all right. It just AWS is asking the use case. It doesn't really matter. Click onto the I understand and click onto the next. If you want to give any description, totally fine, okay. On this page, once you create, click onto the download CSV, because you can do this only once, all right. You have your access key and this is my secret key. Now in this tutorial I will just show you my access key and a secret key, but in this tutorial I will show you my access key and a secret key, but I will most likely delete this user once this project is complete, so that my credentials are safe, okay. So you can click over here, open this, all right. And this is my access key, so I'll copy this access key and put it over here, and I will copy my secret key and I will put it over here, okay. And then you select this and you click onto the run. Invalid value, what I have to do is actually I have to put this onto the single quote, not the double quote. So this is single quote, right? This is single quote and this is single quote, okay. And now I hit the run. Okay, this is secret, all right. Cannot the session does not have the current database, okay. Over here I haven't selected a database, so if you click here, you have to, yeah, oh, click here, click onto the Netflix, no, movie lens, all right. And this is my, I think what we used in the last one, okay. You can manually, you can, okay, so you can manually click onto the Netflix and the raw, all right. Or settings, this is fine, all right. Or what you can do, you can execute these command, okay, which is the same as use warehouse, this use database movie lens, and the use raw. In our case, we actually, let me just drop this Netflix one first. Go here, okay, because this is creating some confusion for me, so I'll just drop. We'll just stick with the movie lens, okay. So you can run this. This will basically change the same settings, all right. And then if I create the stage, okay, the stage is successfully created. If I refresh this, if I go to the movie lens, if I go inside the raw, you will see the stages and the Netflix stage, which is basically attached to the AWS, and we have created the direct integration. Now we can start loading our data, okay. So it looks like this, okay. What we have to do first, we have to create the table and then we load our data using the copy command available in Snowflake. So create or replace table, okay, raw movies, all of these are our raw data, okay. So movie ID, all right, is integer. If you want, what you can do, okay, this, let's say movies, I can movies.csv. Okay, this is available. I open this. Okay, so we have the movie ID, title, and the genre. So this is integer, this is string, and this is string. So we will create the table as per that. So movies integer, okay, title, string, okay, and genres, string. Okay, simple. Select this and run this. This will created the table inside. If you click onto this refresh icon, you will see the tables created raw movies. Now this table is empty. So if you do select star from, again basics of SQL, you need to know this if you want to do this project. I have nothing available, which is completely empty. All right. Now what I have to do, I have to load my data from AWS to Snowflake. And for that, we have the copy command available. So copy into, okay, raw movies. All right. This is the table name from, okay, this is the syntax at the rate stage name. Okay. This is my Netflix stage that I created slash the file name. Okay. Inside this, I have the movies.csv. So movies.csv. Okay. And then you have to provide some configuration. So file underscore format is equal to, the type is CSV. Okay. Skip header is equal to 1 because my first header is actually this. If I show you, where is this? The header is our actually the column name. So we skip that and we start loading our data from here, because when we created table on Snowflake, we already created the header there. Okay, so we don't need header here. And then, okay, and then we have to do field optionally, okay, underscore and closed by this single quote. All right. And then if I execute this, let's see, it is, if you have provided the right secret key and the access key and created the stage properly with the right path, your data is loaded successfully. Okay. And now if I do the same, select star from raw movies, here you will see all of these data are available. Okay, this is the exact same data that is available in the file. Toy Story, Jumanji, whatever it is, right? All of these are available here. All right, so we were able to load our movies data. Now I'll give you a challenge. Okay, this is a quick challenge. Just try to load all of the same data, all right, that is available inside this. Pretty simple. All you have to do is just do the create table statement. What you can do, open the individual file one by one. So after the movies, let's say if you want to load the tags data, right? So open the tag file, see the column names, okay, and the understand the type of it, create the table, okay, and then copy the data, right? Pretty simple. You just have to copy paste these two steps again and again for all of the files. If not, I'll just show you. I already have the query ready, so I'm not going to just waste time. Okay, raw movies is done. We will do raw ratings, raw genome. I'll just paste it. You can also find this command from our GitHub repository. All right, so I'll try to execute this one by one. Netflix stage. All right, so movies is done. I'll try to load this ratings. Same, create table. Let's say it is loading. Okay, if the files are quite large, for example ratings, right? So in the ratings is actually 500 MB file. Okay, ratings and the genome score might take some time to load. Okay, might take around like 1 minute or something, because again it is connecting to the S3, it is transferring all of the data to the network, but the files are loaded as you can see. All right, then we have the raw tags. I'll load that. This might be faster. All right, then the genome score and the genome tags, I'll just execute this together. Okay, so it will execute and load all of the data from the S3, and then lastly we will have what, raw links. Okay, let's wait for this to finish and then we can move forward. I hope you are doing this by yourself. At least it's pretty simple, so not that complicated. And then this part, okay, raw links. All of the data are loaded successfully. If you want, you can refresh this. Okay, you will see inside this raw schema of the movie lens, you have all of the tables available. If you click onto any table, all right, and if you click onto this preview table button, you can see actually all of the data are available. Okay, it's pretty simple. Snowflake provides you all of this functionality. I can put this by just dragging down. Let's say raw movies, okay, raw ratings. Let's check this. Click onto this, click onto this button. It has like 20 million rows. Okay, and you can see the preview of the data. All right, so we have the data available. Now starts our DBT execution, because once we have data available to the Snowflake, now we can do the DBT thing, right? Do the macros, all of the models creation and everything. So till now we have just set up the project, okay, for the base, like in order to execute things. Now our actual DBT will start. Okay, all right. Now let's move forward. What do we need? Okay, now this part will require some configuration on the side, because we will be setting the DBT on our local, and for that we will also refer some theories. Okay, I have created, this is our data vidya notes available, freely available, open for everyone. You can just go to notes.datavidya.com and you can always, these are our mainly the course notes. So if, let's say if I go to the Kafka and let's say I want to understand the producer and consumer, I have a complete notes available. You can actually learn everything whenever you want. My internet is not working properly, but let me go to something else. Yeah, you can see all of the notes are details properly given here if you want to revise it in the future. And the best part about this notes is basically it is, let's see if I go here, uh say if I go to this, okay, it is connected based on the topic. So in Obsidian, you can actually create the connection with the each topic. Let's say inside the uh, Snowflake or the Spark, we have the partition concept. So it is available in the both. So you can have a proper connection created between different topics. So it creates the proper network of everything. Okay, so it's pretty interactive, useful. You can directly search the particular information and get it. So inside this, we have the DBT notes available. Also, I've created for you to refer anytime you want. You can always come here and actually refer it. Okay, and I have given the steps to actually install everything. Okay, so introduction and modern architecture, we have already looked into it, the same on the PPT, just added here for your reference. Okay, for the installation we have the two things. One is we have the DBT cloud, and second is we have the DBT core. Okay, DBT cloud is a web-based service that provides a development environment, job scheduler, and document hosting. Okay, this is a web-based. This is the open source command line version that you can run locally on your servers. We will be working with the DBT core because it is open source freely, and mainly you will be using this in the real world. This works the same way, but it just gives you a good UI. We want to work onto the open source level so that you can actually do the job on your local. Same is available on the cloud also, nothing different. There are some features here and there, but exactly the workflow is same. All right, core DBT core is the exact same thing. Now we will be installing all of these things into our local machine. All right, and I have given steps for both the Mac and the Windows. Linux also has the same steps, so you don't have to worry about that. Okay, let me see if everything is recording. Yeah, everything is fine now. So first of all, what you can do, you can open your terminal. All right, and you can also do this step manually, but I'm just doing it over here. So I'll just do cd document. All right, ls, I'll go to my YouTube folder. Okay, and I have around DBT masterclass created. Okay, so I'm inside my DBT masterclass folder. All right, you can choose any folder that you like. You can just create the make dir, okay, and create a folder as Netflix, okay, DBT. I'll just create that in my any location. If you want, you can do that. Okay, and open the Visual Studio Code. If you just write the code dot, okay, this will open the Visual Studio Code. Not here, I don't want to open here. CD inside the Netflix masterclass. This is Netflix DBT, and I will just do the code dot. If you don't have the Visual Studio Code installed, you can use any editor that you want, uh, or you can just download the Visual Studio. So download Visual Studio Code, all right, and download it, install it, and you can actually map the actual folder over there. Okay, pretty simple, not that complicated. Now once you have this, right, click onto the terminal, click onto the new terminal, and we will have to execute some command over here to actually initialize the DBT project. Now, the first command we have is like creating a virtual environment. What the virtual environment is that whenever you install any package on your local PC, it actually stores inside the it actually uses your local configuration, right? But in this case, we will be installing a lot of packages. We might need some different versions of packages also. So we don't want to mess with our local uh, packages. So what we will do, we will create the virtual environment so that all of our packages actually go inside that. Now to create the virtual environment, I think the steps, I don't think I've given the steps, but if you don't have the virtual environment, just search online install how to install virtual environment, okay, in let's say Mac or Python. Pretty simple. You can use the chat GPT, but it is basically pip install virtual environment. All right. And then using that, you can actually, or you can do the virtual environment, something like this, or you just do the chat GPT to install the virtual environment. Not that I think I already have it installed, but all you have to do is just write the pip install virtual environment. Okay. You do something like this, pip install. Let me just do this virtual environment, and see, I already have the requirement satisfied, but in your case it will install it from the scratch. Once you have that, you have to write this command. Now for the Windows and for the Linux, okay, what I'll do, I'll just create a new file here, commands.sh. All right, and I will write all of the commands here. So for Windows, we have, instead of this, I'll just do the SQL, okay, because we will also put some SQL code here. Right. So for Windows, this is the command, and for the Mac, if you already created this, okay, this is the command. So I will just do virtual environment. Okay, what this will do, this will create one folder here. All right, and all of the virtual environment, and then I can just do this venv, wait, ls, yeah. So ve, I think the command is source, activate source venv bin and activate. Yeah, I remember this. Okay, this will make me go inside this virtual environment available here. For the Windows, you have to use this. Okay, venv scripts activate, it will be like this, but inside the Mac, you have to use source like this, source venv bin activate. Okay, and if I just do Python here, you will see, for me, based on my local PC, the Python version is 3.11. all right, I'll just do the quit, and I'm inside my virtual environment. As you can see, if you are inside this venv and all of these things comes, you are inside the virtual environment and start executing all of the code. The first thing is, the first package that we want to install is this pip install dbt dash snowflake is equal to particular version. Okay, this version. Now it will start installing this package. This will give us direct flexibility for DBT to connect to the Snowflake. So it will install the DBT also, and it will install the connector to the Snowflake. Both of the things will be directly installed in your local PC into that particular virtual environment. Okay, so it is installing for me right now. You can just go online and just see DBT compatible, DBT compatible Python version. Which version should I choose? It gives you the proper understanding that if you are using this Python version, you can use this DBT version. If you are using this Python version, then it is compatible with this. In our case, it is this. So anything more than 1.4 version, it is fine. Okay, in our case, we have used 1.9, so totally fine for that. Okay, now this is done. Okay, in my case, DBT is installed. I'll just clear screen. Python is DBT is installed, and this is installed. What? The Snowflake, right? Both of the things are installed. Now we have to create one root DBT folder. Okay. Again, all of these things are set up that you have to do most of the time that when you're working with the project. So over here I have given the same thing. If you want to individually install for snowflake, dbt bigquery redshift, you can do that. You can directly use the brew also if you want to do it. Okay, this part we will do the setup right now. Before that, we have to create one directory. So in the Mac, let me just put this here. Okay, uh, this is like the root. What is this? Yeah, terminal. Yeah, this is like the root of dbt folder. So you just have to write mkdir tilde backslash slash dot dbt. This will create the dbt folder. In my case, it already exists. If you are using Mac, execute this command. If you are using Windows, execute this command. Okay, basically we are creating the root dbt folder, so every metadata information, all of these things about the management of the dbt will get stored inside that. Okay, once this is done, now we can actually initialize the dbt project. Okay, and the command for that is basically dbt init my dbt project. Okay, in our case, we will give like dbt init. Okay, and we'll just give Netflix. Okay, and I hit enter. Now it will start asking you all of this information. So first, the profile Netflix already exists into this profile. Do you want to continue and override this? In my case, I already have the Netflix available because I worked with this project. I say yes. Okay, now enter a number, right? Which database would you like to use? Over here, let me just zoom this. Okay, if you guys can see. So over here it is asking, we already have only one snowflake because we installed pip install dbt snowflake, right? If you remember this command, when we execute it, okay, dbt snowflake, it installed the snowflake, so it is giving us this option. So I'll just write 1 and I'll hit enter. Okay, now I have to connect to the snowflake database. Let me just make sure you guys can see this, because yeah, this is very bottom. All right, I think you guys can see it. Enter a number. Okay, account. Can I pop this out? No, I think it's fine. Yeah. Okay. All right, so now enter account information. Okay, so you need to enter the value for the account. Now you have to add the account identifier value. Where do I get this? Go to your snowflake. Okay, over here, click onto the bottom left, click onto the connect a tool to snowflake, and you will find all of the information available here. What it is asking is that it is asking for account identifier. So click onto this first one, copy. Okay, it's not with the dot but with the hyphen. Copy the first one and paste it here. All right, the username, right? In our case, the username we have given not here. Okay, when we created this, the username is our dbt. Okay, so I'll give dbt the login name. Okay, the password, right? We have given the password as dbt password 123. I'll paste this. And okay, before pasting this, first we have to select either we are using password, key pair, or sso. I'll say one password and just paste it. Okay, you will not see the password. Okay, then the role, in our case the role name is transform. Warehouse name, okay, in our case the warehouse name is compute wh. Database name, okay, the database name in our case is this movie lens. All right, and the schema is our raw schema. Yes. Okay, and the third is just keep the one. This is the basic configuration, and inside this root folder, as you can see, .dbt profile ym, this information will be stored. So if I show you in the terminal, cd slash users slash Darshil dbt. Okay, if I do ls profile YAML, see the profile YAML is available. If I do nano YAML, you will see the information about account. Okay, for the, let's say, for the Netflix. see for the this is available movie lens, all right. uh Password is available, role is transformed, schema is raw, and everything else is same, right? So this is actually getting stored inside this folder that we have. Okay, let me just come out of this, right, and clear this. So this was the first configuration and the connection with the snowflake. If this is done, right, now we can actually start doing our actual DBT thing. So if you click onto this Netflix now, you will see a lot of different folders are created for us. These are the many different folders available, and again, you don't have to worry about it right now. We will tackle it one by one. We will move forward and actually try to execute them uh, as we move forward. Okay, but our DBT project is created. If you reach till this section, that means you have successfully initialized your DBT project, all right, and connected with the Snowflake. So we can see our DBT project available. Click onto this DBT project or YAML. This basically has the mapping to the different folders that we created. For example, model path, okay, is connected to the models folder. Analysis is connected to the analysis folder. Test path is basically the test folder. Okay, so when I was saying that you can do the testing, you can do the modeling, you can do the snapshot, okay, you can do the analysis, all of these different things has a different folders created for that, and we will go one by one to understand them, okay, in detail. Now before we move forward, you can install few extension, all right. Just click on to this button, extension, or this one, and just write DBT. Okay, and you will see this power user for DBT. You can install it. In my case, I already have that. Or you can also install the DBT formatter. Basically, whenever you write the DBT code, we should have get like the proper keyword highlighting and everything for the DBT. For the icons, right, if you want to see that, you can just say click onto the VS Code icons, all right, and install this also, so that you will have this kind of beautiful icons created based on the folders. Okay, if this is basic setup is done, then we can move forward and start actually writing the models. Okay, in this models we have the example folder created. What you can do is just delete that folder. We don't need it right now. We will create our own models. So let's try to go and see our nodes. Okay, now question is, what is DBT models? Now we are starting and trying to understand different parts of DBT that we have understood over here. Okay, when we actually saw this, right, we had like the test, deploy, document, transform, and everything. Okay, now we will go to the individual parts and try to understand that. Now DBT models are the SQL statements that transform your data. Simple. Okay, it is a SQL statements that basically transform your data. Models are basically SQL script. Okay, so why are we calling it model? Just a fancy name, right? It is defined as a .sql files, contain a single select statement. All right, it can produce a table or a view depending on the configuration, and can reference other models and create a dependency graph. This is very important, right? So understand, DBT models are basically SQL script, .sql script, right? It basically is a select statement. It can either produce table or the view. Main important part to remember is that it can reference other models and create a dependency graph. So for example, let's say you have the 2000 lines of SQL script. So in that SQL script, you create some table, temporary table, you create some CT statement, then you reference that table onto below to, actually do more logic. Then you will actually, start carrying out that different logics one by one. In DBT, you can divide this. Okay, so I create a table over here, then inside the another script I can reference that table to actually do the work. That will understand. Now creating model is pretty simple. Okay, you inside the model folder, you can create any folder that you want, all right, and actually create a simple script. Let's try to do this by ourselves. Okay, what we will do, right click onto the model, click onto the new folder, and write as staging. All right. Inside the staging, now we will have to create the staging for all of the different things. Okay, let's start with the movie one. Okay, so I'll just say right click, new file. I'll just say source movies.sql. Okay, and inside this I just have to write a simple SQL script. What the SQL script is, with let's say raw movies. Okay, I'll do select star from, uh, if you go and you have to provide this path, which is movie lens dot raw. Okay, so again, our DBT is connected to the snowflake, so we can execute anything, all right, anything onto this local PC, and it will run on the snowflake, right? So we can, what we are doing is that we have, let me just put this, all right. What we have here is, okay, onto snowflake, this is, let's say this is our entire snowflake, all right. Snowflake, first we have our raw data available, all right, raw data available. Now using that raw data, we don't want to mess with the raw data, okay. We always keep the raw data as it is, that is, that came from the multiple source. Now we create the staging layer, okay. This is my staging. On the staging, you can do few modification if you want, okay. The reason is that in case you mess up something, you always have the raw version available to you, so you can always use that. So on staging, if you want to modify something, or if you just want to exactly replicate, okay, from raw to staging, you can do that, just to keep the one version, the better version out of it, okay. And everything you do is after the staging, so we will keep the raw as it is, and we will just copy our raw data to the staging data. So this is what we are doing, is that select star from movie lens dot raw, okay, and raw underscore movies. Where this is coming from? It is coming from this, the tables that we loaded, right? It is available inside the movie lens dot raw underscore movies, this one, all right. It is coming from here, and then I'll just do the select. Let's say I want to change few things here, okay. So from the movie ID, I'll just rename it as movie ID, all right. And then title is title, and genre is genre from raw movies, okay. This is called as a CTA statement. Again, basics of SQL, not going to explain this, but this is a simple thing, right? We have the width, okay. You give the table name, you select the data from the snowflake, and you execute this. Now if I come here, let's say onto the terminal, not this one, terminal, new terminal, okay. Make sure you are inside the virtual environment, and now you can just do the DBT run, all right. I hit the enter, and it will start doing few things, okay. Now runtime error, no DBT project found, okay. So I am inside, uh let's say ls, okay. I have to go inside the Netflix folder where our DBT is, okay. And if I do ls, you will see all of the DBT folders like models macro. Make sure you are inside the Netflix folder, and you do the DBT run, okay. What is this doing? What this is doing is that DBT, this is happening, okay. Concurrency target as dev, all right. Start SQL model with src, error creating SQL model with raw dot this one. So what this is like, I'm getting some error. So there is an error inside my code, and as you can see with movies, I have to put as here, all right. I think that was the issue. I'll just again do the DBT run, okay. And now in this case, concurrency, start SQL model as raw src, okay. Created SQL view model for raw dot src movies, okay, and completed successfully. So pass one, all right. As you can see, the one model found. There are some macros that we don't want to worry about it right now. This is what we have done right now. If I go to my snowflake, okay, if I refresh this, you will see a view is created, okay, view created. And if I want to, check this, you will see all of the data are available. Movie ID is like movie underscore ID, title and genre is available. What we just did, right? Pretty simple. Might not make sense right now, okay. So what we just did, pretty simple, nothing different, okay. What we did, we created one model, okay, a DBT model. We understood, right? A DBT model is a simple SQL script, okay. that executes the select command. All right, over here, simple SQL script that executes. It produces table or a view in your data warehouse. All right, it produces a table or the view and can reference other models and create a dependency graph. This we will check when we actually move forward. But right now we just did these things and it created a view. Now you might ask, why did it create a view? Why it did not create a table? Okay, the answer to that lies into actually the default version of DBT is basically, if you go to the DBT project, okay, you will see the models, you will see the Netflix, okay, and here you would have to define the configuration. So right now it is being materialized as the view. So all of the table, okay, inside we had the example folder created, right? So initially when we deleted our example folder, it has the default behavior of creating it as a view, and by default it will create it as a view only. Okay, so we have a concept inside the DBT called as a materialization. Okay, if you just go online and just write DBT materialization, you will be redirected to this link. Okay, and you can understand different types of materialization available. We'll just try to refer this, okay, documentation, so that we understand. Now materialization are the strategies for persisting DBT models in the data warehouse. There are 5 types of materialization available in DBT. One, so there are 5 types. So there are 5 types of materialization available into the DBT. Basically, it is like a strategy, or kind of like you can say the configuration that you want to define that, do I want to create a table? Do I want to create a view? Do I want to create an incremented table? Do I want to create the ephemeral or the materialized view? What are the difference between all of this? It is available onto this documentation itself, and we'll try to go one by one to understand that. Okay. First is this is the how the actual DBT project file you define. For example, folder name materialize as table, folder name materialize as view. You can define this for the different models available. Okay. First, let's understand the view. So if you have the basic understanding of SQL, okay, this might be quite easy to understand. View is the same as the database's views, right? It basically does not store any data. It only stores the SQL query to actually create the data. So pros, no additional data is stored. Views are on top of the sources, will always have the latest records in them. So whenever you run select query on top of the views, in the backend it actually, okay, executes this query. Okay, create or replace view, this src movies as with, and it will execute this. So if I just copy this and let's say paste it over here into the new file, you will see this is the actual raw query, okay, that DBT converted and stored onto the snowflake as a view. So create or replace view, okay, creates this view. These are the column name as this entire DBT model that we use. This is the raw version. What DBT provides us is the abstraction. So when we write this, okay, it basically creates a view on top of the snowflake, right? We can change this materialization to table itself. This is the core of DBT, right? If you understand all of this, you will master the DBT, because most of the people get confused over here only. Like, what this table? What is this view? It is nothing. When you create a view, it basically stores the query information and creates a. It does not. So when you create a view, okay, it basically rebuilds or it refetches all of the data from the actual table, and then gives you the result. On the other hand, when you create a table, okay, as a materialization, your model is rebuilt as a table on each run via the create table as. Okay. Now the pros is basically it is used for the fast query. Whenever you select materialization over here, okay, inside if I say table, okay, this the actual data of the table will get stored inside the table. For example, let's say a particular table, let's say movies, okay, movies take around 10 MB of the data storage. Now, when you create a view, it only stores the query to actually generate the view. So that it might store only the, let's say, 10 KB of data, right? Not 10 MB, 10 KB, because it is only storing the query. But when you create a materialization as a table, it will actually create the copy of it, and create it as a table. Okay, so it actually has a data. That's the reason it actually gives you the faster result. This is very important. All right, this is a table. Okay, we will understand this when we actually do it on the hands-on, but understand the concept right now. Now, cons are also there, like it can take a long time to rebuild, especially for the complex transformation. If we have changed something, new record in underlying sources data do not get automatically added to the table. Okay, it might be the case because it is a static table. View is basically the query stored. Incremental. This incremental model allows you DBT to insert or update records into tables since the last time that model was run. So if you have understood about the concept of upsert, right, incremental data loading, you can use this type of materialization to actually achieve that. Then we have the ephemeral, are not directly built in a database. Instead DBT will interpolate the code from an ephemeral model, dependent model using the CTE, and you can control the identifier. This is basically this basically happens when you don't want to create a table, you don't want to create a view. All you want is to, write a logic that generates some output and use it to some other query. Okay, totally fine. Okay, if you don't understand that, totally fine. We will visit this when we do the hands-on practice, but just understand this is one type of view or materialization available. And then we have the materialized view. Okay, it allows the creation and maintenance of the materialized view in the target database. So in Snowflake we have the materialized a table or a materialized view available. So it is basically the combination of both views and the table. So it also updates the underlying data but also stores that. So for example, materialized views are the combination of views and table, serves the serves the use case similar to the incremental models. It's basically you will get the materialized view combines the query performance of the table with the data freshness of the view. The main reason you use the view because every time it runs the query, okay, so it takes some time to actually fetch the result. But in table the actual data are stored, but you don't get the data freshness. Materialized view give you both of them together. You can also do the incremental run and do the configuration. This is what we call as the materialization into DBT. This is the core. Understand this. This is the core of DBT, right? Everything you do in DBT work on this concept. Again, there are many more concepts, but this is the core of it. So understand this. So let's try to revise that, right? What we have discussed till now. One is we understood about the models. Models are basically simple SQL script select statement that is used to create either views, tables. Okay, what are views and tables? Are basically the materialization form inside the DBT. You can have views, you can have tables, incremental data, ephemeral, and materialized views. These are the different types of these are the different ways you can store your data on site the data warehouses. Okay, understand that. Now next step is to we have to create a staging for all of the raw or the raw data that is available. Okay, and it is pretty simple. Let's say I go here, I create a new file, and just do the src underscore ratings dot sql. Okay, now you can do this by yourself, but all you have to do is just use the underlying table and create a view out of it. Okay, so we will create it for all of the tables that we have created the raw version. Okay, so we will create the staging table, the source movies. Okay, just like that we will create I'll just put the query here, okay, and explain you. With raw ratings, select raw ratings, okay, and select it as user ID movie ratings, and we actually do some uh, casting over here, okay, which is just a number format, and we convert it over here as a rating timestamp. Same way I'll create a new file. Let's say src tags.sql. Okay, uh, I can do this. Okay, same thing. Select tags, put the query. Let's say go with the links. Okay, I'm just trying to fast forward because it's the same thing. So src underscore links. We are just creating all of the models to go from raw to the staging. Okay, same raw links, and I select the data. Then I'll create for genome tags and genome score. Okay, so create new file src underscore genome underscore tags dot sql. Okay, this is my genome tags, and then as new file src underscore genome underscore scores dot sql. I paste it over here. Okay, this is my score. And now if I open the terminal, hopefully I'll clear this and I do the DBT run. All right, this will run all of the 6 models that we have available here. So found 6 models. Macro you can ignore. Concurrency 1 thread. Target is the dev. All right, start with the genome score. Created genome score, genome tag, created genome tag, links created, movies again created, ratings created. Okay, all of these different things are created. Pass 6, no warnings, no errors, no skip. Total 6 things are created. If I go to my snowflake, if I refresh this, you will see the 6 views are available over here. All right, okay, so the models are ready. So all of the models that we created are getting created as a view inside our DBT. But what if I want to create a table? What if I want to create the incremental table or ephemeral? How do I do that? We will do that right now. Okay. So in this example of this, okay, once we have a staging data, okay, you understand that when we store our data into the data warehouse, what we create is a dimensional model, which is like we have the dim table in between and we have the fact table in between, and we create the dimension table around it. This is the concept. This is the core concept of the data warehouse. Foundational concept, I think I have covered this into the data engineering masterclass also, that is on the YouTube available. You can go here. Let me just open this. Okay, okay, this one, this masterclass, just show you. Over here I have covered most of the things that you need for the data engineering, so you can go and check this. Okay, about the data dimensional modeling, but in general it is basically the fact table in between and the dimensional table around it. One thing is that before we go forward, I want to say that we are building a platform also for the same. So if you want to practice if you are preparing for the data engineering rounds, you can actually come here and practice by building the data model and the dimensional model. Okay, it is a new platform that we are designing, so you will be able to actually build the table, uh, you know all of the data model, dimension model, and then submit it to actually get the AI review about everything that you do. So whenever you go to your data engineering interview, you will be prepared by building the data model, dimension model. Like right now, like it is giving me like full assessment, like completeness, ideas for improvement, your entire analysis, like how complete it is, the relationship accuracy, normalization, integrity, business alignment, more recommendation how you can improve. Just wanted to show you what we are building here, because while we are on this topic, it's much easier to understand. Okay, so after the staging, what I want to do is that I want to create a this dimension model. Okay, dim and fact table. Okay, these are the 2 tables that I want to get created on my this project. Okay, so I have the raw staging dimension. This is loaded manually. Okay, this is my raw tables that we loaded using the from S3. This are views created using DBT models. Okay, and this will be our, let's say, uh, data warehouse. Okay, actual data warehouse structured. This is table. Okay, we will try to use the incremental table here also to understand the concept, but this is the core table. Now if I have to have this configuration, what I can do over here, where I tell you just remove this. Okay, and then you can add something like this. So Netflix tab plus materialized view. All right, and then we will create a dim folder inside this. Okay, and it will be materialized as table. Okay, understand this. We have the Netflix available. Okay, Netflix table, Netflix folder available. So all of the models will be automatically get materialized as a view. By default, we are keeping it as a view. But for the dimension, we want to actually create it as a table, and we will actually do some transformation here now. Okay, so what you can do, right click onto the models, create a new folder called as a dim. Okay, so we have a staging available, we have the dim available. Let me cut this. Okay, right now we don't need this. So dim available, staging available, and now we will write some code for the dim. And for the dim, here where the fourth point, all right, the fourth point that we discussed here, can reference other models and create a dependency graph, will come here. And this is the core, right? These, you might say that, okay, Darshil, it's a simple thing, right? Now, why do we have to create a separate file? We can directly execute it on the data warehouse and do all of these things. What are we even doing here? Now we'll understand what are we doing. Okay, so I go to the dim. What I'll do, I create a right click, dim underscore movies.sql. Okay, I create a dim table, dimension table that I want to create. And this, I will write it like this. Write it with me. With src underscore movies as, okay, select star from. Now there is a syntax, okay, available in DBT. Two curly bracket, okay, just hit the double space. Reference src underscore movies. Okay, now what we are doing is that, you see this staging, inside we have the src movies, the file name. We can directly reference, basically the output of this script can be used here. All right, if we were to do differently, it will be something like this. Okay, which is basically we create a view first and then use it onto this movies. Okay, but using this reference, this is the core of DBT. Again, using this reference, I can refer this staging data. Okay, whatever the output this staging src movie gives, I can refer it here. Okay, create a temporary table and then execute some transformation logic that I want from. Okay, now I write my transformation block here. Okay, using SQL, completely creating a dependency graph. The thing can reference other models and creating a dependency graph. What I mean is, this model that I created src movies, I can use it here. I can join multiple models to create a new model. Let's go forward. Okay, movie ID. Okay, let's say I want to capitalize this, so I'll just use function init cap. Okay, initialize cap. Trim, I'll just use trim variable. Okay, doing some basic transformation. Title as, I'll give the new name as movie underscore title. I'll use a split. I'll do the genres. I'll do split the genres by this and create genre array. Okay, something like this. I'm doing some transformation. Okay, and I'll just put the genres. This is the dim movies created. Go to the terminal. Okay, you can execute the dbt run completely, or you can just execute the dim movies also. We'll just execute entirely. Okay, dim dbt run. I'll just execute this. Okay, I have to go inside the Netflix folder. Make sure you are always inside this folder or it will not run. Dbt run. Let's see. Now we have the 7 models. Okay, but you will see S start SQL. See, view model, genome score, view models, tags, view model this, view model that. But here, table model, dim movies. Why it is table model? Okay, because we have defined this into our DBT project that all of the folders by defaults are view, but everything inside the dim folder is materialized as a table. Very important, right? If you go here into your snowflake, if you refresh this, okay, over here, as you can see, the dim movies is created inside the table. Okay, views are over here, the dim movies are created. So as you can see, we have our dim movies created. This is a table, and as per the schema. Now there's a problem. Okay, the problem is we have our raw schema available and we are writing our views and all of the tables into the same schema only. Ideally, we should have a different schema for the raw version and for the development version or the staging version. Okay, what we will do, we have to modify the configuration that we created earlier. This is the piece that I missed earlier. I just want to fix it right now because it might create a problem as we move forward. Okay, so to fix that, we have to go to just let me create the terminal. Okay, when we created our this table, not the table, the DBT project. Okay, we created this folder, right? DBT profile. So we have to move to that. So just do the cd for the Mac slash dot dbt. Okay, profile.yaml. If you are on Windows, you can go to this particular location over there and open it onto any code editor or on a notepad file. It is fine. Okay, in the Mac, I can just do nano and profile YAML. You can use any editor if you want. You can go manually here and also find, like, profile dot YAML. And most likely, if it is not hidden, most like profiles. Wait, profiles dot YAML. It might be somewhere. If not, then you might have to. It's not there. Okay. Uh, this might be the hidden file, so you might have to um open it. Just so if you're on Mac, you can go to this level of folder. If you're on Windows, just go here, just do the cd and open this file to any code editor or the terminal. Okay, this step is not really needed, but I just want to change it. So just see your Netflix output. Okay, all of these things are available here. So schema, I will do it as dev schema. Okay, save it, and I can go to my dbt run. I'll just do the dbt run. So instead of us writing this onto the raw schema, now it will write to the dev schema. Okay, all of these things are on the dev schema. If you go to the snowflake, you will see the dev schema is created. The tables is dim movies and the views are over here, so that we don't clash with our raw that is available. So what I'll do, I will drop this. This is open this, and this database movies draw. All right, and I'll just do the drop table dim underscore movies, drop table, not drop view. Okay, and I will drop src src underscore genome score, src underscore tags. Okay, drop view src underscore links. I'll copy this, paste here, src underscore movies, src underscore ratings, and src underscore tag. I'm doing this just to make our project much more cleaner and just to have that we don't have the issue at the end. Okay, so all of these are dropped. If you refresh, you will see only the tables that we have is available here, which is fine. And on the dev, dim movies is available and the views are available. So our project is much more cleaner now. Again, for this step, if you are still not able to do, pretty simple. If you don't do it, that's totally fine also. Okay, not needed, but just go to this profiles.yaml. If you still have the issue, ask the chat GPT, how do I modify this? And you'll probably find more resources. Okay, so the project is clean now. Let me just put this, uh, remove this. Okay, so dim movies is created, okay, using the reference table materialization model. Now we can do the same. Okay, but let's just try to create more dim tables. So I'll just create like dim underscore users dot sql. Over here I will try to use the two models, okay, with ratings as select, let's say, distinct user id from. Okay, I want to reference this. So src underscore ratings, okay, comma, with comma, not with again, tags as select distinct user ID from reference src underscore tags. All right, select distinct user ID from select star from this rating. Okay, and union select star from tags. What we just did, we just fetched the user ID, all of the user ID details from the ratings and the tags, okay, and then we unioned it, okay, and getting the distinct of the user ID. This is my dim user, okay, this is my dim movies, this is my dim user, which is basically we are fetching from the two different models. These two models are src ratings, that is this one, all right, and the src tags, that is this one, getting it from here and then unioning it at the end. This is done. This is one more table. Let's create one more this dim underscore genome underscore tags dot sql, okay, and with src underscore tags as select star from reference src genome tags, all right, select tag underscore id, okay, initialize cap trim tag as tag name, okay, from this src tag. Simple. Now I can open the terminal again and go to Netflix ls and run dbt run. Okay, again it will execute everything. So there is an error, two errors into genome tags, okay, and dim user. So on this two files we have the two errors available. So in users we have what, dim users with ratings as select distinct user from src ratings, which is fine. Tags as select distinct user id, select star from union, select distinct. I think it should be fine. Okay, so over here I have from, okay, missing, and here from is fine. src tag select star from, okay, this select tag id, this is string. Okay, my bad. I run the dbt run again. Okay, let's see. Success. Dim user still has some issue. Let's try to debug that. With ratings, select distinct user ID from src ratings, fine. Tags as select distinct user ID from src tags, fine. Select distinct user ID from ratings. With select distinct, I think if I run dbt run dash models and give the model name as dim users, okay, if I just want to run one model, the syntax for that is dbt run dash model, and I provide the model name and it ran successfully. Okay, so if I refresh this and if I go to tables, I have the three dim tables available. So for the materialization, okay, my table is done, my view is done, okay, I can have. Now I can go for the incremental and ephemeral also if I want to work with that. So a lot of things are happening. Might be confusing if you're seeing it for the first time, and it's very normal to get lost into all of this, but let me just revise the entire thing right now so that it's much clear. First of all, we have the DBT models till now. Okay, models are basically a SQL script that you write to actually generate some output into the different modular form. So we have created like different models using our raw data that is we loaded from the S3, and we are creating all of this as a view. Using this view, we are creating our dimensional tables, right? We are writing some transformation block. Okay, we are fetching these two different things and writing some. We are like changing something over here, creating the array, creating the dim movies. Like this, we are creating the genome tags. We can create one more model for the fact also. Okay, FCT fact. Here we will write all of our fact models. So let me write like say FCT underscore genome scores dot sql. Okay, and I can write something like with scores as I will refer select star from refer src genome scores. I think, let me see, src genome score only, not scores. And then select movie id, tag id. Okay, from this we have the movie id, tag id, and relevance. And the we'll do the round of relevance to the 4 as relevance underscore score, something like this, from src underscore scores that we have defined on top, where relevance greater than 0. Okay, again, you need basics of SQL clear to in order to understand what is happening here. Okay, we are just writing some basic transformation and filtering based on the relevance score that is greater than 0, because we don't want any 0 value. Now if I just do dbt run dash dash model fct underscore genome underscore scores, let's see. Okay, uh, okay, there's a typo, genome. Okay, it created for the fact table also. If I go to my snowflake, if I refresh this, okay, this is inside the view again. I don't want it inside the view. What I will do, I will come here to the this dbt project. I will define fct as the same materialize as table. Okay, and I will run it again for this dbt model genome score. It created. If I refresh this, fct is here inside the table, and it automatically moved that particular view from the table. So it automatically removed from here to here, so I don't have to manually remove it from the view. It did it for me itself. Okay, so as you can see, dim is available, fact is available. So again, our table is done, view is done. Let's try to do the ephemeral and the incremental uh, this materialization, okay, to understand what is happening. So till now we created our table and the view. Now let's try to create the incremental materialization, right? Let's try to see how they work. And in order to understand the incremental materialization, there is one concept that we really need to understand, that is called as a, let me see if I have this, yeah, over here. Okay, uh this one, SCD, slowly changing dimensions. I think I have covered this in our data engineering masterclass. Let me just revise this from the top view so that you guys understand properly. Okay, so there are many different, we zoom this. Okay, uh, now when we create this dimensional model, okay, this like order table or the fact table in between and the dimension table around, inside the dimension table. Okay, so when we create the table formats like the dimension and the fact, right? The fact tables usually stores the information, the quantifiable information such as product quantity, product price, the weight, all of these are the quantifiable information that is stored under the fact table. But dimension table stores the other information such as product name, description, attributes, user address, location, you can say city. All of these are the dimensions value, right? Categorical values or something that defines or describes something. Now these values do not change often, right? All of these dimension values, like person do not change their basis every day, right? They might do it yearly basis or 10 years basis or something. Product description or product name does not change. It might change 6 months after or 1 month after or whatever it is. Like these are the slowly changing dimensions. Now, in order to tackle that, we have like different ways to tackle it. Now in order to tackle it, we have different ways. Okay, first is called as the SCD1, slowly changing dimension 1, type 1. In this, basically we directly overwrite the value. For example, in this case the city is New York. Okay, the city is New York. Now if we are following the SCD1 pattern, we will directly replace the value of that city. Okay, but the problem with that is that we will not have the idea of what was the value in the version 1. So this New York is get replaced by the New Jersey. We will not be able to track the changes. So in order to track that, what we will do, we use the SCD2. In this, every time there is a change, we add a new row with all of the details without deleting the previous values. For example, Adam is currently living in the New York. Okay, and we add one more column as is active. Which one is the active right now? So Adam is in the New York, false. Let's say Adam moved to the New Jersey, and then after that he moved to the Miami. So the New York and the New Jersey is false, and the Miami is right now true. That basically means, okay, this current version is the active and the right version right now, and all of the other version is the false one. In this case, we keep track of the previous version also, but we have to add a new row every time. Instead of that, we can also add a versioning. Okay, instead of this is active, we can add a versioning like 0, 1, 2, and whichever is the max version is the latest detail. So in this case, it is true. Or you can use the date range also. For example, New York start date is this and the end date is null. So if whenever the end date is null, that means it is a current active one. So as you can see, Adam was in New York from January 1, 2020 to 25 March. Then he moved to 25 March onto New Jersey till the 1 December. And currently he's in the Miami and the end date is null. So there is no end date. So that means whenever there is an end date as null, okay, we can figure out that this is the uh, active one. This 3 version falls under the SCD2. And then we have the SCD3, that basically means we maintain only the partial version, not the complete history. So instead of adding the additional row, we add the extra column like this. So current city is the New York, the previous city is null. Let's say he moves to New Jersey. So the New Jersey is the current city and the previous city is the New York. Let's say he moves to Mumbai. So the new city will be the Mumbai and the previous city will be the New Jersey. Like that, we just keep the track of the partial one. And SCD6 basically combines 1, 2, and 3. So you keep track of the previous city, you keep track of start date and end date, you also keep track of the is active. All of these things when we have to do, right, in our when we follow our data engineering life cycle, it is very quite tedious to actually perform this, because you have to make sure everything is correct, right? You have to write a logic in such a way that you keep track of the existing data, you scan the previous data and make sure everything is working properly. Whenever you have to update, you have to keep in mind of this pattern, because let's say you have thousands of tables, you might miss some of the information that okay, we are following SCD2 onto this, so that is the reason we have to update this top table in this particular way. We have to pull the information from this table into this by writing that is active and make sure the end date is null, so that only we get the current data or the latest data. Using DBT, this becomes much more easier, and this is what the incremental table that we talked about over here, right? In this we talked the incremental. Okay, it is used for that. It is used for insert or update records into table since the last time the model was run. You can try achieve this kind of thing using this. Okay, so let's try to see that. uh let me go here. So the first thing we will see is just the incremental one, okay, where whenever we add any data to the source table, it automatically gets reflected onto the incremental table that we created. And then afterwards, we will see the example of the SCD2 by understanding the concept of snapshot. All right. So right now, go here. So inside the fact table, just create a new file, fct underscore ratings dot sql, okay, and we will have to define some config like this. So on top, this is the syntax of dbt config, and then you write materialized is equal to incremental, okay, on schema change is equal to fail. For example, let's say we create a table and on the source table, the schema changes. We will not be able to incrementally update this fact table. Okay, that is the reason we keep the if the schema changes, this will be fail. This config overrides any config that you define onto the DBT project. For example, over here, currently it is considered as a table, right? But right now, over here, we are manually defining this one it as an incremental. So this will take the first place. Okay, if we don't define anything here, this will be considered as a table. If we define something, let's say incremental, this is considered as an incremental table. All right. So make sure you can define the config like this onto the table script level with src underscore ratings as select star from, okay, refer src ratings, okay, select user id, movie id, rating timestamp from src ratings where rating is not null. Okay, now this is where the incremental logic actually comes into the picture. So this is the syntax, okay, and this syntax you can always refer it from the documentation. So if is incremental, okay, you have to write function like this, okay, and it's like the percentage and if, okay, so this is the if statement. If this is incremental, okay, then we are continuing with this logic, okay, so where this is this and rating timestamp is greater than select max rating timestamp from this. So let me explain you this one so that you understand properly. What we want to do is that whenever any new row is added into the source table, right, whenever any new row added into the source, let's say ratings table, whatever the max time is, okay, max timestamp available into this one, let's say the max timestamp is, let's say 5 p.m. and the new row gets added into the table, let's say the 6 on the 6 p.m. So what it will check, it will check this table. This table means this fact ratings, fact rating tables. From this table it will get the max rating, which will be like 5 based on the previous record, and the current rating into this table or the current timestamp into this table will be 6 p.m. because the new row got added. This way, this condition will satisfy. So 6 is greater than 5. Okay. If this is satisfied, then it will automatically update the fact ratings. So the logic is pretty simple. Let's just write it here. So in the SRC ratings, which is my base table, all right, base table, the max timestamp was 5 p.m. Okay. When I created this fact rating table, now new row got added at the 6 p.m. This fact ratings, which my fact table is, okay, had 5 p.m. till now. Okay, it is not updated yet. But based on this condition, okay, after this new row got added at the 6 p.m., it will select the max rating from this. In this case, this is equal to fact rating. Okay, so it will check fact rating. It will see, okay, the max timestamp is 5 p.m. All right. From this rating timestamp comes from this one. Okay, source rating. Okay, it comes from here, SRC rating, and the max timestamp right now is a 6 one. So it will check 6 is greater than 5, condition met. Okay, so this is continuation with this only. So where rating is not null and this is true. Okay, in this case it is true. So this table will automatically get updated. This is the core logic of the incremental materialization. It updates your table based on the new data or the condition that you have defined. So if we were to see this in action, all right, let's just try to see how this actually works. So let me just uh, let's say first let's create this fact rating. Okay, so I'll clear this and I will do the dbt run model fact underscore ratings. Let's see if this creates or if we get any error. Start SQL. Hopefully no errors. Okay, it is completed successfully. If I go to my snowflake, okay, fact rating is available. What I can do, I'll just write a script as over here I have to change the schema to dev. Okay, I'll do select star from. Okay, you can directly write movie lens dot dev dot fct ratings, order by rating timestamp in descending order. Okay, limit 5. All right, I execute this and over here what do I see, right? I see user ID movie and this particular timestamp. Okay, 2015 03:30. Okay, has this particular timestamp available to it. Let's say I insert a new data. Okay, so this is available inside my fact ratings. Now what I will do, I will, this is my fact ratings. This is my base table, SRC ratings. Okay, I will go here and this particular table, SRC rating, is actually a view. Okay, and on the view, I can't insert update directly. View is basically the virtual table that is just running a SQL script. So if you see the definition, it is basically running this particular query, raw ratings again and again onto this particular table. Now, if I have to modify this particular table, I have two options. Either I mess with my raw data, which is this one. Okay, this inside the raw schema, which is this one, but I don't want to touch that, right? I want to keep the raw data as it is. So what I will do in this case, let's say in this case I want to modify this ratings and add some value just to see my incremental logic works or not. I will modify and I will change the configuration of this particular table from view to table. Okay, and it is something like this. Pretty simple. You just have to write config materialize is equal to table. All right, and now just pay attention to this. Okay, if I clear this, this SRC ratings is inside the dev schema SRC ratings. Now if I do dbt run model SRC underscore ratings, enter. All right, this is the table model SRC ratings completed. If I refresh this, it is removed from the view. It went into the table. All right, now I can do the same, select onto src underscore ratings. Okay, I execute this. Okay, and this is the uh, highest timestamp that is available over here. Okay, for this particular user, for this particular movie. What I can do here is I can insert a value. Okay, so what I will do, I will insert into src ratings, insert into src ratings, uh, user ID, movie ID, rating, and the rating timestamp. Okay, values as, let's say I add one value on top of this. Instead of 86, it is 87. Movie ID, I'll just keep it same. A rating, I'll give 4.0, and this timestamp I will copy, and I will just add, let's say instead of 30, I'll do this as a 31. Okay, let's try to insert this. I hope this works. Unexpected 23. I think we have to put this in between then. Movie ID. Okay, let's try to put this between. I thought, okay, it's movie ID. Movie ID. Okay, it inserted one row. If I see SRC ratings now, okay, it added this particular uh, row here. All right, and then let's say if I see this one. Okay, right now we are seeing the same. Okay, which was this particular row. It is still not updated. So now if I go to a terminal and if I run dbt run dash dash select fct underscore ratings and hit enter, this will only, okay, this is the SQL incremental model, so it will only run this incremental part, okay, and try to see if there are any new data available or not. Okay, so finish running one incremental model. Okay, pass one, total one. Okay, and now if I select this FCT ratings, you will see the new row got added automatically into the incremental table itself. Okay, I just updated this one and it also captured this particular new data that we added. So it incrementally updating. We did not create the table from the scratch, only we ran the script with this select, okay, and it updated the incremental data of the DBT. This is the core of DBT, right? We did the views, we did the this what do we have? Tables. We did the incremental. We can also do the ephemeral, okay, which can be something like this. So if you go to, let's say, dim table, create the new file as dim movies with, let's say, tags.sql. All right, and I will do config materialized is equal to ephemeral, okay, with movies as, let's say, select star from refer dim movies, okay, comma, tags as select star from refer dim genome tags, scores as select star from refer, let's say, fact genome scores. All right, and then we will join all of these together, right? We will do select m dot movie id, m dot, let's say, mm, before this we'll just do from movies m, okay, left join scores s on m dot movie id s dot movie id, left join tags t on t dot tag id is equal to s dot tag id, and then I will do m dot movie id, m dot let's say movie title, okay, m dot genre. This is basic SQL, so I'm not deep diving into like what's what we are actually doing here. We are just trying to create a one table by combining these three different tables as a movies with the different tags. We are just joining the tags with this movie and the score. So s dot, let's say relevance score, something like this. Okay, and let's say if we try to run this model, let me just clear this. DBT run dash dash model dim movies with tags. I run this, running this, finished running, and you see it did not create a view, it did not create a table, it did not do any in incremental. What it only did, it just ran and it exited. Even if you go here and if you try to refresh this, you will not see anything. The reason for that, in ephemeral, okay, ephemeral models do not directly build into the database. Instead, DBT will interpolate the code from an ephemeral model, dependent model using the CTE. Simply, it will run in the backend, and any model that is using this, okay, any model that is using this uh, particular information, okay, it will get it from the backend. So all of these information such as movie ID, title, genre, tag name, relevance score, you can use that behind the, instead of creating a new table. For example, let's say if I um, do we have any use case for this one? Okay, you can do the simple fact table. Okay, new, let's say ep movie with tags. Okay, just to see how it works, it is basically, I can do something like this. I'll copy this. So select star from, let's say src fct uh hmm, movie, okay, with tags, and I will do dim movies with tags. Okay, and I can just do select star from this one. If I run this, dbt run model ep, let me just copy the name here. Okay, starts running ep movie. If I go onto the snowflake now, if I refresh this, you will see the ep movie. If I click here, you will see the same information: movie title, id, genre, tag name, and the relevance code. This is null. Might be some issue with the data level or something, but right now what it did, it basically, using this ephemeral table, right, which does not actually give you the output, you can use this data to any of the SQL logic that is available, right, any of the logic that is available, and then it will work. And then you can use that over here to do any transformation, join new table, while this table not getting created onto the database. It is just getting inside the memory, and you can use that. That is the ephemeral table. I will just delete this. We don't need this. This was just to show the example. All right, this much is done. So this is the core. That is the reason we are spending so much time on to understanding views, tables, incremental and ephemeral. We have done most of the things. Materialization view is the same as a combination of this incremental and the table. Exactly works on the same concept. Okay, so DBT models are done. These are the different types of models that you can use, okay, and materialize it. Now let's try to move forward and try to understand the different more concept of the DBT. If you are watching this video till here, that means you are quite serious about data engineering. All right, so make sure, first of all, if you haven't liked this video, do like the video, because it's very complicated to actually bring these ideas into one single project to explain you in the simple way. So if you are finding this helpful, do give it a like. Okay, and again, if you want to learn more about data engineering, of course we have a courses available. You can go to the data vidya combo pack, and these courses comes with the like around 16 plus projects. You can see all of these projects are available. More than that, we have a new coding platform available also. uh, just if you want to practice for your data engineering interviews, right now we are preparing for the version 2, but while you see this video in the future, you will get to see the version 2, where you can come here, practice the coding interview round. So Let me just go to the version 2. You will see something like this, okay, the UI, where you can get the coding challenges like 30 days of Spark, SQL. You can prepare for the coding round, you can prepare for the database round, you can prepare for the technical round, and more things are coming. So coding questions are available. You can come here, you can prepare for DBT also. So if you want to practice, let's say, DBT problem set, we have like Python, PostgreSQL, and PySpark available. We also have the DBT support available. You can see things over here. For the coding, we also have the data modeling round preparation that I just showed you. We have the learning part that will give you the quick understanding. So all of these things are available. There are a lot of questions free, so you can just try it out if you like it. Do give me the feedback. We are just trying to help you crack data engineering interviews. Okay. So this was everything till now. Let's move with our project. So we have done this. Now there are few more concepts that we have to understand. Okay, DBT models are done. Simple DBT models we understood is just a SQL statement that can use any other models to actually build the lineage graph. Now we will work with the seeds and sources, snapshot, testing, macros, and all of the other things one by one. So let me just go here. So the new concept, right? Seeds and sources in DBT. So seeds in DBT are CSV files that you can upload in your data warehouse. They are useful for static references like the country code, zip code mapping, and the product categories. This is what I told you initially, right? If I have a file available on my local PC, and if I want to directly create a table out of it without me uploading, creating table, going to, maybe directly connecting with the S3, I have it available on my local and I want to quickly create a table. I can use something called as a DBT seed. Pretty simple. Let's say in this, collapse this, and I go here and I have a folder available as a seeds, right? Let me this file you can find onto the GitHub repository. I will create a new file as seed underscore movie underscore release dates dot csv. Okay, and this has like release date of the movies ID, and the release date. You can just write something like this or copy it from the GitHub repository. You'll find the link in the description. Now movie release date, yeah. Now it is pretty simple. Let's say I have some files like this available and I go to the terminal, and over here, and the only command that you have to write is dbt seed. If I execute this, it will go inside the seed folder. How does the dbt know it should go inside the seed folder? Is because we have mapped over here. So seed path is this. Okay, it will go inside the seed folder. It will see, okay, seed movie release dates is available. I will go, whenever I run the dbt seed, I will go and create a table over here. Okay, and as you can see, rows are available over here. So any small file or any file that you want to create directly from the local PC, you can use dbt seed. That's it. That is all you need to know about the seeds in the dbt. All right. There are ways you can configure the seed, right? You can use the reference model also. So now if I want to create a new model and if I want to use it somewhere, for example, if I go here and let's say I, I create a, we will create a mart inside this. So inside the models, create a new folder and give it a mart, right? This is like the final mart that we create based on a specific use case. So dim fact table is created, staging is created, mart is created. Over here, we will use the, this is the seed table that we created. Okay, so create a new file and give it as mart movie releases sys.sql. Okay, and over here we will use that. So first we define the config materialize as table. All right, with fact ratings as select star from refer fact ratings. Now seed dates as, let's say, select star from refer what seed movie release date. Okay, this you can directly refer because it is being created, uh, it's already available over here as a model. Okay, so you can create this and it is available here also, so you create it based on that. select, okay, from FCT ratings, F left join seed dates, D on F dot movie ID is equal to D dot movie ID, and then we can select the column as F, all of the columns from the S, and case when D dot into this release date is null, then we'll just give it as unknown, else known movie, right? Something like this, and as release info available. All right, something like this. And if I do DBT run dash dash model mart movie releases, okay, let's see if we get any error. It's running, okay, successful. If I go here, if I select this mart movie is available, you can get a quick overview of that, and based on that, unknown or known is generated. All right, so this is the concept of seed. You can use it like the way you use the other models. They are dependent on each other. Okay, this is done, seed is done. Everything you can do it over here. You can also configure seed more things, like, you know, if you want to keep a particular schema, you can add it something like this. So my project, you add country codes such as where care, this should be like this. You can do a lot of configuration as per your requirement. Second thing is that configuring the sources. Okay, now sources in DBT, sources in DBT represent the raw data loaded into your data warehouses. Configuring sources provides several benefits. First is the documentation, where the data comes from, testing capability of the raw data, and ability to check if the sources are fresh. What it basically means is that inside the models, you can create a sources.yaml file that will keep track of the different things that we want to do. Okay, here's how it looks like. Okay, sources. There are two things, sources and the schema. So first we will check at the sources. So create a new file as sources.yaml inside the models. Okay, inside the models, right click, new file, sources.yaml. Over here, just give version as 2, and now you can define different sources here. Basically, let's say name, or in our case it is Netflix. Okay, schema, raw, tables. Okay, and now over here, let's say all of these raw table that we have, right, inside the, not in this raw schema, all of the tables that we have, it is coming it as like raw genome score, raw genome tags, links, movies, and like this. We can rename it. Okay, we can rename it and call it as per what we want. For example, let's say if I want to give name as r underscore movies. Okay, and let's say identifier as raw movies. Okay, what this means is that instead of using the tag next time raw movies inside our staging, let's say over here we are using the raw movies over here, we can directly use something like sources. Okay, and the sources, something like r movies, r underscore movies. What this will mean is that we have defined our own set of rules inside the sources, whatever we want to do. Okay, and based on that we can use that. Same goes with the all of the other things. So let me just paste it. This is just a concept, this is good for the conceptual understanding. Okay, so that is the reason I'm just showing you this. All right, let me just make sure this is indented. Okay, something like this. So I can create identifier name. Okay, there are more examples given here. So for example, if you want to give the database name, database you can define the schema inside it. So inside the schema, you have the tables. Then you give the name of that description you can provide for the documentation purposes. For the particular column, you can give more description. For example, customer ID is the primary key for the customer. Test, right now we haven't covered that, but test are basically if you want to test it based on if it is unique or not null. You can also keep the freshness. We will also look into this. Okay, like this you can define the sources, and you can use the sources in the table, something like this. Okay, for example, let me see. uh, for example, I have defined this. Let's say if I go inside the movies. Okay, and over here, instead of using this, now I can do sources. Okay, uh, in my case it is Netflix and r underscore movies. This will work the same way as it was working for the using the this this way, right? But here we have more control because we are making sure it follows our own way of writing things. So this is pretty much about the seeds and sources. Seeds are basically the local file that you want to load to your data warehouses, and the sources are basically the raw data that is loaded on your data warehouse, and you want to take some control over it by providing the right documentation, where it comes from, testing capability if you want to add that, and also you can add a freshness of the data, right? This is pretty much about the sources. Now let's move forward and let's try to understand all of the other files, such as uh, what are snapshots, right? What are macros, DBT packages, analysis. We have a lot of things to cover, so we'll try to cover them one by one. Understand this, right? What we are doing is that we are trying to build a project. Okay, while building a project, we are trying to understand individual components. Might be overwhelming if you are seeing it for the first time, so that's totally okay. Okay, just move forward, go with the vibe that you will understand eventually as you start following me. Okay, and will start making sense afterwards. Now we have the slowly changing dimensions. The concept of SCD we have already covered. What we will do, we will try to see this concept properly, okay, in implementation by using the snapshot. Okay, because in order to configure SCD in DBT, we have to use snapshot. What are snapshots? Snapshot is a DBT or built-in implementation of type 2 slowly changing dimensions. They record the state of the mutable table over time. Okay, so it tracks the changes of the specific column, add the effective date such as it is valid from and valid true, and maintain the complete history. So this particular thing that we saw, okay, this if we want to do it, we have to use a snapshot concept available inside the DBT. And there are different strategies that we can use. One is a timestamp strategies. Okay, so this strategy uses the timestamp column to identify changes. So it's something like this. There is a target schema. You provide the key name, you add the strategy name, and you give the updated at, like if you want to add like this particular column was updated at this particular timestamp, you can add that. By running the DBT snapshot, you can actually run the snapshot and it will check the changes in the last snapshot, creates the new record if there are any changes, and updates. So basically, you have a table. Okay, let's say SRC ratings, we have the table available, and we create a snapshot of that. Now every time any new changes occur to SRC ratings, and whenever we run this command DBT snapshot, it will go inside and check, are there any new changes, updates, or insert available? If yes, I will implement those into that snapshot and tables will get updated automatically. Okay, we will try to see this into action properly so that we understand everything. Okay, this is also very important concept because you will be doing this into real world to manage the snapshot. So let's try to do that right now. What I will do, I will go inside my DBT. Okay, and over here, what do I have? I have a snapshot available. Okay, and we will try to do it on the tag. So I'll create the new file. I'll say snap underscore tags.sql inside the snapshot folder. Okay, over here, and the syntax is like this: percentage. Let me zoom this. Snapshot snap underscore tags. Okay, and then we define the config as target schema. So I want to create all of my snapshot into the snapshot schema. So snapshots, this is where I want to create them. Let's say unique key. I have to provide the unique as a primary key. So unique key, I will give it as user ID, okay, movie ID, and the tag. So I will create one surrogate key based on this strategy as timestamp. We will use that updated at, okay, we have the column as a timestamp as a tag timestamp, and comma invalidate invalidate hard deletes is equal to true. Okay, uh if this is done, then we do the, this is the start of snapshot. This is okay, select here. We can use a custom package available inside the DBT. We'll talk about it right now. Let me just remove this and we'll just do the user ID, movie ID, tag, okay, and I'll cast this tag timestamp as into this ntz timestamp format, because this strategy timestamp requires you to follow this particular timestamp format, or that you will get the error timestamp from reference. I'll get the src tags. Okay, yes, pretty fine, and limit 100, and I will do polar percentage and snapshot. Okay, pretty much done. Now there's one more thing. The one concept that we have to understand is the surrogate key. Now in data warehouses, surrogate key is a concept that when the data is coming from like the RDBMS APIs or external system, they have their own keys available, such as user ID, movie ID, tag ID. But when you go into the format of creating dimension table or the fact table, you have to create your own version of key to keep track and to join different tables together. Okay, your own version that doesn't necessarily mean that the source system will understand. It's like your own unique key that you are creating, and that you can create it using that is what you call as a surrogate key. I'm not sure if we have covered this into our this one. I think, yeah, this concept I covered it inside my data warehouse course. But the surrogate key concept, if you just Google it, surrogate key, okay, you'll understand is a unique non-meaningful identifier used in database, particularly for the tables in data warehouse when the natural keys are not suitable. For example, there are chances that in order to track the different changes, user ID, movie ID might not be enough, right? Because there might be some duplicates of that user in that particular movie. So we use user ID, movie ID, and a tag to differentiate and create the new unique row. And you can use that using DBT package. Okay, DBT underscore utils dot generate surrogate underscore key. Okay, inside this we have to provide this list of keys as raw key. Okay, it's not raw, it's row key. All right, now where does this package comes from? Okay, let's go here, DBT package. Okay, now the software engineers are frequently modularized code into the libraries. These libraries helps programmers to operate on the leverage. They can spend more time focusing on their unique business logic and less time implementing the code. For example, let's say if I want to generate the surrogate key, I will have to write my own logic to create the surrogate key. But these are the package available. I can directly use this to do my work. Okay. In DBT, libraries like are called as a packages. These are different packages available, such as transforming adword to the Facebook ads, uh, to do the generating SQL union together to relation. For the Redshift, we have some privileges. For the Stitch, we have packages available. If you want to define a package, you have to create this file called as a package.yaml. That you can do it onto the root level. So right click onto the Netflix, click onto the new file and give it as a package dot packages packages dot YAML. Okay, and it is pretty simple. You just have to write something like that: packages tab dash package dbt dash labs under slash dbt underscore utils. There are a lot of packages available. Version, you can define a specific version if you want. If not, it will pull the latest version. Now once you define this, all you have to do is go to the terminal. Okay, make sure you are inside the Netflix folder. Okay, let me just clear this. You just have to write dbt, and the command is dbt deps. Okay, deps. If I hit enter, it will installing the dbt labs. Okay, or utils version this up to date. Now whenever you run this, okay, it will basically use this package, and if you go here, it will create the new folder where it will install all of the requirement for the dbt package. Okay, it is also available here. Okay, this particular chapter, let me just go through it so that you understand. dbt packages are the collection of models, macros, tests that can be reused across the project. They provide way to share common transformation, leverage community created functionality, and maintain the modular code. For example, you define the package name, version, okay, like utils, expectations of there are any external package from the GitHub. You can also do this. How do you install package? You just write the bash command dbt dep. It will download, install dbt packages and make it available to the project. Like dbt utils, generate surrogate key, and you provide the key name. It will create the surrogate key for you. You can read through this. You will understand most of the things. Just wanted to put it over here so that we are on the right track. Now, once this is done, right, our snapshot, this looks good. What we can do now is just run a command. Let me just clear this. dbt snapshot. Okay, if I hit enter, it will go inside the snapshot. There is one snapshot that is found. Okay, start snapshot snap tags. This is one. Let's see. It created the successfully, completed successfully. If I go and refresh this, you will see inside the dev, you have the table. View movie. Yeah, inside the movie lens, it created the new schema as a snapshot. Why it created the new schema? Because we have defined the target schema as a snapshot one. All right, and over here it created the snap tags as a table. As you can see, it will have something like this: row key, this is like the surrogate key for us, user ID, movie ID, tags timestamp. Okay, this is std id, you can ignore this. Updated add, valid from and valid to. SCD type 2, it which is basically the last update, it is valid from and valid to. Okay, let's try to see this SCD into action. Create a new sheet. Okay, and we'll just try to see if this works properly or not. You're working in the dev. All right, what we will do, select star from snapshots dot snap tags, order by user ID and dbt valid from. Okay, in the descending order. Let's just try to see the latest data. Okay, over here, what do we see? I see a row key, a user ID 18, movie ID as 414, Mark Waters. Okay, and he has, let's say he's valid from like 2009 to 2009 04 24 at this particular time. Okay, Now what I will do is that, what is the root table of this is src tags. Okay, we have available over here. So I will try to update some value. Okay, snapshot, like we are trying to understand this scd2, like when we update our this one. Let me explain this. When we update any dimension value, all right, this one scd2, when we update any dimension value, are we able to keep track of all of these different things? So start date, end date, all right, we want to keep track of all of these different things. That functionality is provided by the dbt. So now we are going to update some data into this. So for this I will say update dev dot src yeah, dev dot src underscore tags. Okay, set tag, in this case the tag is, let's say, Mark Waters. Okay, and I will say tag is equal to Mark Waters, this not yeah, Mark Waters returns. Okay, something like this. I will update this and tag timestamp. I will give as, I will castrate the current timestamp to match the same format as timestamp underscore ntz. Okay, where user underscore id is equal to 18. All right, for this user I am going to update this particular thing. I have updated this. Okay, updation, I must target a table, update table. Okay, it is like this, update table, not okay, src tags. Why it is not running? Update statements target must be a table. Okay, let us check. I think this is a view. So inside dev view, so this is a view. Okay, we have to convert this view to the table also, because we are modifying few things. So over here inside our staging tags, just like we did it for the I think ratings, yeah, I will do the same for the tags also. All right, table, and then I will have to open the terminal again. Clear dbt run dash dash models src tags, not tabs, tags. All right, this will run. Now this will move my src tags from here to the table. Now if I update this, okay, uh, row updated. So if I try to see this table, let's say the base table, here src tag dev.src tags. Okay, this is my base tables that I'm user id, this one. Okay, select star from, okay, I have to just do where user id is 18. Okay, okay, and the tag we updated onto this Mark Water returns is updated onto the source table, which is our base table that we have. Okay, if you see this right now, all right, right now we have this 18. Okay, it is still Mark Waters. Now we'll just do something like onto our terminal dbt snapshot. Okay, I'll just execute this. I can select a specific snapshot also, but I'll just run the dbt snapshot. It is running the snapshot, completed successfully. Now if I execute this snapshot query, okay, and if I run where u- user user id is equal to 18. Execute this. Now you see we have the two rows, mark water and mark water returns. Tag timestamp was 2009 and this is 2025. All right, this is the today's date. Okay, and here you see data valid dbt valid from dbt valid to new row got added and this is null. So current active one is this one. Okay, we just implemented this SCD in the most simplest way possible. We did not have to do any complicated things. We just create a snapshot. It keeps track of everything that is happening. Whenever we run the snapshot, any table that has the new data, deleted data, inserted data automatically gets updated with the timestamp properly. So we understand that, okay, this was valid from here to here, this was valid from here to here. This all was done just by creating a simple snapshot, okay, and giving a basic logic. This was everything about the snapshot that we had to understand. Okay, snapshot are used for the implementing type 2 slowly changing dimensions. All right. Oof. Let me have water. Now the major thing is completed. There are few things that we have to understand now. Okay, one is the testing one, then we have the macros, packages done, documentation, and then analysis. Okay, so we'll just try to cover this in next half an hour to 1 hour, and I think we are pretty much done with our project. And I'll show you the advanced concept that you can learn, how you can learn, where you can learn. But this is a good start. I think if you are enjoying, do let me know in the comment section that you actually reached to this section and you have completed the snapshot one, because again, a lot of people start this project, in between it gets difficult, so eventually they give up. But this is like the full masterclass of dbt. You will not find it anywhere for sure. I have put a lot of effort, like 2 weeks of effort, to create this entire thing. So do let me know if you actually reached to this section, and if you are listening to me right now, that I completed this project till the snapshot one. And now let's go with the testing one. All right, if you remember this PPT, not this one, this PPT, snapshot, transform, which is basically the model. Now we will check the test. Okay, document, we will also check all of these different things that we just saw it on the theory level are actually making sense one by one. Okay, transform or the models are basically simple SQL script. Snapshots are used for the SCD2. Okay, testing we will understand right now. We'll also understand the documentation. Now, so in order to create a documentation in DBT, we have to define all of the information about the things that we have available. And while we do that, we can also add a testing information. Testing information basically means our data is coming. We want to make sure that only data, okay, this data should be unique. Like the user ID should be unique across the table. If the user ID is not unique, it should not pass. Only data with, let's say, uh, not null data should not be passed onto the tags, or the metrics data should be greater than 0. At least there should not be any data that is less than 0. All of these information we can easily do using testing, and we'll look right now. So now we will understand about the testing. Okay, so DBT supports two types of tests. Okay, one is a generic test and the second one is a singular test. Generic tests are the reusable tests that can be applied to the multiple models, and the singular tests are the customized SQL scripts that test the specific condition. We'll understand the both. First one is the generic test, right? These are the already created tests by the DBT given to you that you can directly put and get the test ready. For example, are the reusable assertion about your models comes with the 4 built-in generic test. Okay, one is the unique test. Basically, test that values the columns are unique, such as the primary keys, movie ID, user ID. All of these should be unique in that particular table of the primary key, not null. Again, based on the name, you can understand the column should not have any null values available to it. Relationship. This basically tests the referential integrity between two different tables. So that should actually match. There should not be any issues. For example, over here we are using movie ID. In the second table also we are using movie ID. It is basically creating a reference between two different tables. So it should have a proper relationship created, right? If the movie ID is available onto, let's say, the second table, but it's not available onto the primary table, that means it is wrong. So the reference should be proper. And the accepted values, because these are basically the predefined values that you should have. For example, inside our table, we have, let's say, tags, right? So tags, we can put the mandate on the tags that only these are the tags that are allowed. So inside the dev, let's say, tables, I call src tags, and these are the tags available. Okay, mark waters, all of these are the different tags available. We can like restrict onto the column level that only these tags should be passed, no other tag should be available onto this. You can also do this onto the generic testing accepted values. Okay, so you define it like this. You create a file such as test.yaml, or you can create a file such as schema.yaml. Okay, and define all of these things, such as you define the name, you define the description, then you define the column where you define the single column name, and then you define the test, such as it should be unique, it should not be null. Email, it should be unique, should not be null. Status, it should be these values only: active, inactive, pending, something like this. Okay, then we have the singular test available. Okay, singular test are the custom SQL script that you define by your business logic. For example, singular test, you can create it inside the test folder, put it over here, and every time you run something dbt test, it will make sure, it will go to the this particular table and make sure this test pass or not. Okay, it will make sure that this particular test case actually passes, but that means that amount should not be less than or equal to 0. It should be always positive. All right, so these are the tests that you can do. To run the test, it is pretty simple. dbt test, if you want to run a test on a specific thing, such as onto this model, onto this test type, or type of this test, you can also do that. Okay, and you can also configure the test onto the schema level, such as values are this, and this is just a warning. So if I want to, let's say, this values such as active, inactive, and the pending, new value comes, it will just give you the warning rather than it will giving you the error. You can also define the configuration, like, let's say, if the amount is greater than, you know 5, or if the amount is greater than, if the amount is less than 0, then you give the error. If its amount is greater than less than 2, then you give the warning, something like that. Okay, all of these different things you can do. Over here it is the email. So if the unique email condition is set, and if the unique if the email if the email occurrences are greater than 10, then you give the error. If the email occurrences are less than, let's say, greater than 5, then you might not give the error, you just give the warning that, okay, if 5 duplicates are available, something like this. You can always do that. Okay, so these are the tests we have available inside the dbt. Let's try to just experiment it. We have like covered the core of dbt already. Okay, these are the extra layers or the masala on top of the dbt that we want to keep track of, because this is what makes dbt powerful. You can test, you can build, you can deploy, you can orchestrate every single thing at one place. Okay, and documentation is also the magic. When we actually reach to the documentation, you will understand that. Okay, so inside the dbt model, okay, right click onto the model, new file, and give name as schema.yaml. All right, and over here we can start something like this: models, okay, dash name, let's say dim movies. Now we give the description as per our understanding. Description as dimension table for cleansed movie metadata. Okay, this is my own description that I want to give. Now I can give the columns inside this. Let's say first is name, movie id. All right, I give the description about this. Description, primary key of the movie, and test, I will give the test as it should not be null. All right, then I will do dash name, movie title, and I'll say description, um standardized movie title. Okay, and the test for that is also not null. Okay, and then let's say name, genre, array, description, list of genre in array format. Let's say name, genre, and the description raw genre string from sources. Now, why we are writing the description on the first place is because when we generate the documentation, these are the description will be shown onto the final documentation. Okay, so that we understand, okay, what this movie title actually means, what this genre array means, right? So any new user, new engineer joins your company, okay, wants to understand, okay, what is the meaning of this genre array? They can just see the, okay, list of genres in array format. I understand that, right? Like this, you can create, let me just paste this, okay, so that we don't waste time writing the same thing again and again over here. Okay, like this for dim movies, I can do it for dim users. All right, I provide a description column, dim genome. Okay, I can do that. Fact ratings, I can do that. Okay, here I have like given the relationship to refer to dim movie type based on the field. This is fine, and all of the mainly all of these are the null. So like this, you can define all of the test. Best is DBT test documentation, and you will get all of the details on how to write a proper test. Okay, over here, okay, like this, unique, not null, refer to relationship, accepted values, like this, so that it's much more easier to do that. Now, if I want to test this, what I have to do, open the terminal. I will clear this and just write DBT test. It will automatically go into the test. It will start testing. Okay, start, not null, test, pass, 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 all of these tests are passed. Let's see, let's try to add, let's say, unique constraint to the DBT user. All right, and the unique constraint to the tags. Most likely they don't have the unique value, but let's try to test this. Do we get any error or not? I think it is clean, so we have all of the unique constraints available also, so we don't have any issues with that. Let's try to see relevance score if we can add any. Mm, mm, mm. What we can do is that inside the using this, okay, we will create our singular test, and we will go here. Do we have test folder created for the test? Yeah, test is created. Where is the test target? I don't think we have test, so we'll create the test folder, new folder, test. It already exists. Why I can't see it? Okay, I'm getting blind. Oh yeah, it is created. It was red. Okay, I will create a new file, and I will give the test name as what are we testing, right? Schema. This schema, where is the schema? I want to test based on the relevance score, all right, that is available inside the fact genome score. So I will define the generic test. Okay, uh, right click onto the test, create a new file, uh, relevance score test dot sql. Okay, something like this. And this is my model. I'll copy this, and I will make sure genome score refer from here. Okay, genome scores, and it has movie ID, tag ID, and the relevance. So I will go here, ID and relevance score. Okay, and I will put the relevance score, and I will make sure relevance score is at least less than, let's say, 3. Okay, just a random condition, I want to test it. What I will do now, I will open the terminal here, and I will do the DBT test again. Let's see if this test actually pass or not. All right, okay, it failed. Relevance score test failed because got the result configured, error Now let's try to see if the relevance score is less than 0 or not. Let's see if this test case pass. Yeah, it passed, right? So all of our relevance scores are more than 0. So it means all of the values are positive. So this is the power of testing, right? Before the data is moved forward, we need to make sure all of our test cases pass. All of these data are unique. All of these data make sense. There should not be any garbage value. All of the values should be accepted value only. If this is done, then only move forward or else show us at the end. This is the power of DPT. You can test it on the fly over here itself. You don't have to move forward. Okay. So testing is done. Okay. Package is done. Macros. Now macros is going to be little bit tricky. We will tackle the macros one. All right. Macros are basically like a function available in the programming language. Nothing else. Okay. We'll tackle the macro. But before the macro, I want to show you the good thing, which is the documentation. Right. It's pretty fun. So I want to just cover that part right now, and then we will cover the macro thing. So what you have to do, you don't have to do anything right now. Just write this command dbt docs generate. Okay, this is the command available. Just execute this. What it will do, there is a bad descriptor available inside our schema.yaml, I think. Let me copy the schema directly so that okay, let's try to run this dpt docs generate src movies. What is this? Error in src movies sql source is undefined. Okay, over here we have the error. In the sources we have raw movies. Okay, over here raw movies are movies. I think it's not sources, it's just source. Okay, maybe that is the reason we are getting issue. dbt docs generate, I think it should fix now. Building catalog, all right, that got fixed. Catalog written, all right. So it already wrote our documentation, and now we just have to run one command, which is dbt serve. So if I go to documentation first and show you here, right, dbt provides a comprehensive documentation system, allow you to document model column test. It creates a documentation websites and share your knowledge across the team. So you do the dbt generate and then you do the dbt docs serve. This will basically start a web server in your local pc, and then you will be able to see the everything. So this is our entire documentation generated for us. For example, in our Netflix we have all of these different sources available. Okay, you can see information such as tags, account admin, table, packages, Netflix. This is the relationship, contract, sources, okay, size, all of the column information given here, sample SQL script is given here. Okay, you can see the description, columns, SQL for entire thing. Inside this, we have the Netflix models available. So again, if you click on Netflix, it will say this is auto-generated document. If you go to dim, click on to dim movie, you will see unique tag ID for tag, clean, human readable. Let's say dim, all of this primary key for movie, standardized movie title that we written, list of array generated format. So you can understand about this. Reference by, you can see the entire relationship depends on, let's say, src movies. Okay, this particular thing, this depends on three different tables such as fact genome. So this is based on the project, this is based on the databases. So all of the databases that we see on the snowflake, right, dev, raw, snapshot is available. I can click onto something, I can get most of the information available over here, the code, a description about the columns if you have added, snapshot information if you have added, all of these different things, data type and everything is available. and automatically generate it for us only. We don't have to do anything, right? All you have to do is write it on the code. So if any person who comes joins the company and wants to understand how our entire data system is structured onto the DBT level, they can come here. They can just see, okay, this is the dev, this is the raw. We can add more information about the particular database, particular table, particular column. All of these things we can add it over here, so that any new person joins can get the full information about what is going on. All right. Now the best thing is this one. If you click onto this, okay, it generates the lineage graph for you. So if I go to the, let's say, dev movie, okay, let's say Netflix, and if I click here, all right, onto the root level, if I click here, you see I get the complete graph of what is happening, right? I see the source links, SRC ratings uh, is actually creating this, okay, seed movies, and these are being created from here. Then we have the ratings of R movies, SRC movie, dim movies is created, and then with the tags. So you get the complete information about how your models are structured, what is dependent on what, and what do we get at the end of it in just one single page. And then you can also play with over here, right? If I don't want the models, I can remove the snapshot. I can have that. I can add few more things, such as select, such as SRC movies. I think there's a proper format to that. Dash dash uh, dim underscore users. Okay, I can get that. If I want all of the dim values, I can do that. If I want to exclude, such as Netflix dot r underscore links, I can update it and I can get that. Okay, so I have the power to update and filter things as per me. This is the powerful feature of DBT. Everyone likes this because you get every single thing front of you without you doing anything. Okay, the document thing we talked about is this only. You can deploy the document, you can test it, you can transform it, you can snapshot it. Again, there are version controlling, alerting, logging. All of these are the advanced concept that we can look forward. Okay, but right now we understood. You can stop this web server by Control C. Okay, and it will interrupt it. Let me clear this. The documentation is also covered. Now we will look at the macros and the analysis, and then we are mostly done. And then we will talk about some of the advanced concepts that are available. Okay, but I think most of the major concepts are covered right now. Let's just try to work with the macros a little bit, and then we'll move forward. So the macros are basically the functions that we create, okay, and we can pass the parameter to actually do some kind of work. So instead of, let's say, in our test, right, over here what we did is uh, we were we wrote one SQL function, okay, SQL script, to actually check this. But we can actually do the same for, let's say, relevance score is getting repeated to the multiple tables. So what we can do, we can define a macro and just send the table information. It will return the result. Okay, this way we don't have to write the same logic again and again. This is what the macro is all about. It's a function. They've just given the fancy name to the simple things, right? They could have called this as a function. They could have called the models as just a script, something, right? Testing is fine, seeds are fine, again snapshot is also fine. So again, just their own dictionary, their own words they have created for different things. But macros are pretty straightforward. Okay, nothing complicated, very simple. How you define macros? Right click onto the macros, create new file. Let's say we create a no nulls in columns.sql. I want to check if there are, I want to make sure that no nulls in the columns are available. Start with this curly bracket percentage macro no nulls in columns. All right, and it will take argument as a model that we passed, and here we will have percentage and macro select star from model where percentage will do the for column in adapter dot get column get, I think this is get filter columns in relation. Okay, we can directly use the DBT model. Okay, and I will do column dot column is null, or is null, or percentage end for, and will keep false. Okay, so if it is null, okay, it will return something. If not, it will give the false at the end. Now we can directly go to the test. Let's say this was our test, and we can directly, we'll just put this in comments, and we can directly call something like no nulls in columns, and let's say we give this, yeah, something like this. And if we do DBT test now, DBT test, let's see. Okay, I have to go to the right folder, DBT test, context provider, no object has no attributes, DBT utils. Let me check. In this, I think we directly can use this, hopefully, or I have to check the package name. This is working fine. Okay, one error, relevance score test because of test, that is fine. But I think the other one passed successfully. Macro no null columns. I think the relevance score test, this one is actually failed. Error unexpected in this, unexpected is error number line. Okay, I think the package is different one. We have to use adapter dot get columns in relation. Okay, and then if I run DBT test, I think it passed. Okay, relevance score test passed. That means it is fine. So what we basically did is made sure, instead of us writing this again and again, some kind of like null check or a positive value, we can directly create a macro for that, which is like a function. We pass it. We can either use the custom package or create our own function. Basically, it is checking if it is a null or not, and then based on that, it returns the value. Might be complicated for initially to understand, but it is basically a function that we can call anytime we want to test something, right? Or to do something. Now, this was all about the macro. If you want, you can go here, okay, and you can check. So creating a custom macro, you start with by creating the adding file inside the macro. Then you write the macro, and let's say function name, that is generate schema name. Provide like all of the parameters that you are going to uh, send. Then you define something that says set, is like a defining a variable. Okay, then you provide a condition. If schema is none, then default schema, else this schema underscore this schema, end if end macro. It's like a customized condition you can give, or you can use the built-in macro, such as you use it like this. These are all of the macros that we've been using. So refer, sources, config, target. Okay, all of these macro we've been using till now. Right now we haven't, initially when we started, like reference or source, are these are the macros created by the DBT for us that we are using to refer something, to get some data based on the source, to define the configuration. You can even create the complex macros like column list. For each column, if prefix ends with this, if not, it's like a all of the loop condition. This gets quite complicated, right, when you actually start working in the real world. What you can do for this is use ChatGPT. You can refer the documentation, how to write the if condition. If I want to get something, how do I get this, is there any package available? I can do all of these things by myself. Okay, so this was everything about the macro. And the last thing we want to do is analysis. Analysis is basically final version of analytics that you want to maybe create a Looker Studio, maybe create a visualization, share it to any shareholders. You can do that. So analysis file in DBT are the SQL queries that don't create object in your data warehouse. They are useful for ad hoc analysis, exploratory data analysis, testing complex queries, or generating reports. For example, it is basically a SQL queries where you get all of the table data one by one as per the requirement. You do the transformation logic in between, and then finally generate the analysis file that will give you the output into any file format or anything that you want. All you have to do is that go to the analysis, create a new file, and you can give the file name as, let's say, mm, movie analysis.sql. Now again, you can write a large query as per your understanding. I'll just try to paste it because we want to save time. It's already been more than 3 hours, so what I want to do is just cut short the video and we can continue all of the other concept in the part 2. But analysis might look something like this, okay, which is basically the large query that you get from each and every table, okay, and try to make sense out of it at the end. So for example, let's say this is one of the analysis query where you actually get data from the ratings and join it with the dim movies to understand the movie title, average rating, and the total rating based on the information that you've been given. Okay, so you get the data from the fact ratings, and then you, based on your understanding or your analysis or your business requirement, you try to pull the right columns. Once you do that, then you open the terminal. Here you just do dbt compile. All right, it compiled. Then you can go to the targeted compiled folder. So you do the cd target slash compile, and your project name is Netflix analysis, and you do the if you go here ls, you will find the movie analysis file available. You can also go from here also. So if you go to the target compile analysis movie, this is basically your compiled file. And then if you want to execute this, you can just copy this, paste it onto, let's say, your snowflake. This is your final analysis file. So if you want, you can share the query. You start this, it will start executing, and it will generate a temporary table for you. Okay, something like this. And you can also create a table from this also. So if I want to like create table as movie analysis, as oh, create table movie as, here I give this here, and I want to do this in movie dev. All right, now I execute this, go to movie lens dev table. Where is the movie analysis table? Movie analysis successfully created, movie lens dev. Refresh this. Yeah, it is created. Now I can connect this table to, let's say, right now it is what, 20 limit. Let me just remove this and create or replace. I'll execute this. It will execute, and if I refresh this again, it has 8.5k rows. Now my analysis is done, right? If I want to create any charts, any table, I can, again, this is a small data, so it might not make sense, but what you can do is that there are like a lot of different ways you can generate the analysis. I'll just paste the query for your reference. Okay, like this. You can put this like for analysis, for the rating distribution, user engagement, trends for movie release over time, tag relevance, all of these different things. You can create a single file, generate the analysis, or club it into the one single table also, and then make, based on that, you can create the final table and start visualizing your data. Okay, this was mainly all. Okay, my voice is broken now, but this was everything I wanted to cover over here. Okay. Again, there are more things to the DBT. This can be like the core concept of DBT, but there are more things available. We did not go into a lot of things. That is fine. But there is one thing as a custom schema generation that you can do. These are hooks also available. Like if you want to execute a particular query at particular time or before model is built or something like that, right? Run start, run end hooks on run start. You can do that. Um, you can do the operational tasks such as running a custom task, like defining macro for your operation. You can do that. Built-in operations are also available to check the freshness of the data, naming convention, performance tuning like query optimization, materialization. You can also define onto the more detailed way. You can also integrate continuous integration and continuous deployment, CI/CD pipeline. You can also orchestrate with this Airflow. That is also you can do that. So there are more different things. So what I will do, I'm going to create a part 2 of this video, but that video will not be available on YouTube. That is being a part of the course. And the reason for that is that we are going to cover, or we are going to use the project that is available over here. Very sad, I can't even find that. Let me just open it. So we have this particular project available into our data engineering for Kafka course. We will be continuing we will add the integration of DBT into this project. Okay, we will orchestrate using Apache Airflow so that we have a proper mechanism built over here. So that is what we want to do into the part 2 of this video. We will use this project. So all of my students who have covered already, basic courses can continue with that. If you're interested, you can definitely join. This is the best bootcamp available in the market because it comes with the 6 courses. You will get to learn all of this tech stack, and I keep adding more and more things. I keep adding, so you will get all of the latest value. I don't sell you the, just from the last 2 years or 3 years of recordings. It's just I keep exploring, explaining new things. I keep adding that. I keep updating the course. You also get the access to all of these projects available for or inside the course in each and every course available. Okay, if you are interested, you can understand about the course material by going to the individual course and see what do we cover inside the Airflow. We cover these many things. We go in depth about each and everything. So if you're interested, I highly encourage you to check it out. This is, if you really want to become a data engineer, this is the best resource available on the internet. Okay, and also I've already talked about the platform that we are building, coding platform. Okay, right now this is a separate product, but if you are interested, you can definitely check it out if you want to, prepare for your data engineering interview. We are planning to add more and more fun things over here so that it becomes one place for your data engineering needs. So yeah, this was everything about this video. Do let me know if you like this video, if you enjoyed executing all of these queries. And yeah, I will see you in the next video. Thank you for watching, and keep learning, keep growing, and keep sharing. All right.